So hello, good evening, very everyone. Welcome everyone. Welcome that in the PW NEET English platform, and I welcome you all. That we are gonna covering a second chapter, that is the backlog of structure of atom. Yes, students, in our previous class we have covered some basic concepts of chemistry, and I know many of the students find it very easy, like the concept that we covered, the question that we practiced, the backlog that we covered of your chapters, some basic concepts of chemistry was very much clear to you all, isn't it? Do let me know, Backlog, in the comment section that my audio video is perfectly clearly audible and visible to you all or not. Meanwhile, we'll start with the chapter that is structure of an atom. Yes, everyone. Hi, everyone. Welcome, welcome, welcome. Yes, because of that important news coverage, we were started the class at this time because that important coverage, news coverage of Tamil Nadu medical counseling was there. So that is why we just started our session now, students. Okay. Hi, hello, welcome everyone. All the students who are attending our session, do give a high five. Then the chat section that yes, ma'am, we are attending the session. We are okay now. Yes, 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 yes. Hello, everyone. Welcome, everyone. So just starting the session. Hello, welcome, 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 everyone. Very good evening to all. I hope you all are fine. Okay, so we are starting our session. That is the chapter structure of an atom. Firstly, before starting the chapter, let me make you very clear with this chapter. The chapter contains the topics that are directly on spot asked there in your question paper. Okay, so we will cover the questions as well. We will cover the theory as well. For all the students who are connected there with me, just sit quietly, sit peacefully, no disturbance, no distraction at all. Your 3 hours are locked now. Okay, we gonna take 3 hours to cover this chapter. Okay, maximum as much as we all can, and meanwhile you can parallel tell me the answers that we gonna cover then the chapter. Okay, then the chat section. Okay, class will end at which timing? Okay, what timing it will end? It will take approximately like till 10 p.m. it will be there. Okay, till 10 p.m. Fine, students. Okay, so let us start with the chapter. These all are the topics that we're gonna cover. Okay, the discovery portion, yes, obviously that is very important. The discovery portion that we will cover there in the chapter. Okay, moving on to the models, the Thomson model, the Rutherford model, the Bohr model, the quantum mechanical model. All these model we will start. Okay, then moving on to the quantum number configuration, Schrodinger equation. So all are the topics that we will be covering there in the chapter. Okay, students, so starting on, what is this backlog series? Is this a one shot? Yes, beta, this is a one shot. And what is the backlog series? In this series, in this particular series, we will be covering the chapter that we have discussed there in the class. For all the students who have taken the Arjuna batch, English batch, yes, this is enough for NEET, obviously enough for NEET. You just have to do maximum question practice after the session. That is the main thing that is required for the session. I will cover all the theory portion. Parallelly, I will try to solve the question as well parallelly with the concept, and after that you have to try max to max question by your own. This is the requirement. Okay, today full chapter, yes, we will try to cover max chapter, and we'll see till last if there any topic left behind, we will cover that chapter, that topic in upcoming classes. Okay, fine. All right, are you all guys ready? I am super excited. If you are also excited, do click that like button and share it with your friends as well. Okay, ends at 10 p.m. Fine. All right, starting off with the basic terminology, that is atom. What is the meaning of atom? See, the atom is just termed by the name atomu, that is something that is uncuttable, something that is undivisible, not divided at all. So first theory was given there by Dalton. Dalton was the scientist that in 1808 he have given the theory where he have discussed that atoms are the structures that are very small, they are structureless, spherical particles. We name them as atoms, right? Undivisible, uncuttable. That is the first theory, we can say, the logical theory, we can say, that is Dalton atomic theory, plays very vital role for the we can say atomic structure, or the we can say properties of an atom, was mainly given there by Dalton to the very beginning, right? Okay, moving on to the subatomic particles. Moving on to the subatomic particles. So there in an atom, we all know the structure of an atom to be like this, right? In that atom, we do say that atom contain other subatomic particles as well. For example, if I drew the structure of this atom, it is the nuclear portion. Nucleus to contain what? Proton plus neutron. That are collectively named as nucleons, right? There around this nucleus, there is electron that is revolving around the nucleus, right? So this is another subatomic particle. There are more subatomic particles as well, right? Positron, neutron, antineutrino, right? Right. Ma'am, Heisenberg is not important. No, beta, it is important. Each and every concept is important. We never know that what type of question can ask there in your upcoming NEET examination. So you have to prepare for all the things, yes, but based on the previous year, we can say that some topics are frequently asked topic and some are not, but we will cover all the topics, right? Okay, so this is the, we can say subatomic particles, and there are many more subatomic particles, but the three main fundamental subatomic particles are electron, proton, and neutron. All three are fundamental subatomic particles. Starting on with the discovery of the first subatomic particle, that is electron. So the electron was discovered by, you all know the scientist name, that is J.J. Thomson, right? Yes. So J.J. Thomson was the scientist who firstly discovered it by the cathode ray tube experiment. Now, ma'am, what is it? So we do have this cathode tube where we can say a very low pressure of 0.0001 mm of Hg and a very high potential of 10 kilovolt is applied over to the tube. Okay, the one that is connected to the negative terminal of the battery is the cathode portion, and the one that is connected with the positive terminal battery is the anode portion. So we do have two type of electrode, cathode and electrode. Okay, and a very low pressure is created there inside it. A very high voltage is, you know, supplied over it. So here we can say that some particles do travel from the cathode portion and travel and move toward the anode portion. Now, what are the nature of these particles? What are these? So these basically are electrons. Ma'am, how are you saying that? How are you saying that? How are you assuring that these are electrons? Okay, what are the properties of it? So there were n number of experiments operated over this cathode ray tube. Okay, their experiment justifies the properties of cathode rays, like what is the nature of cathode rays. So firstly, they will start producing from cathode and move toward anode, right? Right, basically what is happening over here, let me clarify you that the metal electrode, the metal of the electrode, it first ionizes. It will ionize by producing the electron like this. So this is the electron of metal. Now any gas, certain gas, for say A2 gas is present inside it. So by the electron of metal, this A2 gas will split itself. This A2 gas will split itself. Now this A2 gas, that is splitting will further ionize itself and produce the electron of the gas along with the electron of metal. So these electrons, the negative entities that you are getting over here, these basically are the cathode rays. The negative entities, the negative particles that you are getting over here are cathode rays. So basically these are your cathode rays, beta. These are your cathode rays. Okay, fine everyone, just listen to me very carefully because this chapter is very, very important. It will definitely help you out in scoring good marks for your NEET examination, right everyone? So listen to me carefully because this is very simple, very easy and direct formula based chapter. You all have to just listen to me carefully and write parallel the notes along there with me. All right, fine beta. So here are these are the cathode rays, means these are the electrons that are comprising the cathode rays. All right, okay. So starting with the properties. First property is they travel in straight line. They travel in straight line. So basically their route is continuously, obviously straight line, right? There is no bending at all. They will continuously straightly travel then in a straight line. Then moving on to the next property, they are not visible themselves. Yes, they are not visible, but how can we then get to know that there is something, some rays are traveling? We can say their behavior can be observed. How? We just over here quoted this backside of the anode. Beta, this is the anode portion. Okay, so this is perforated. Perforated means there are smaller pores inside it. Through that pores, the cathode rays will pass, right? The cathode rays will pass. And when the rays strike the, we can say this coating of fluorescent or phosphorescent materials behind the cathode, when the rays strike to this material, there is a glow production. That glow production results into the we can say indication that something is striking over it, right? So that is cathode. That is cathode rays. Okay, the rays that are producing from this cathode, passing through the perforations of anode and striking towards this fluorescent material, right? And we can say that there is something striking. That means there are certain rays that are emerging from the cathode and moving toward the anode. Right, everyone? This is how we can visualize it. Fine. Very good evening, bache. Very good evening. Yes, they had to. Okay. Hello, welcome, beta. Okay, then moving on to the third point, that they are producing the mechanical effect. What is the, we can say, experiment that proves the mechanical effect of it? So on the path of, between the path, we can say some wheel is just placed there in the path of it. Okay, that wheel will do what? That wheel will automatically pedal out, rotate, right? So this is the indication that some mechanical effect is there with the cathode rays. They do carry some mass, due to which when they are traveling, they are making the wheel to rotate. This is the mechanical effect production, right? So this is about the next point. Moving on to another point, that is electrical or magnetic field, how they impart the change to cathode ray. Usually cathode ray travels straight, but when we put, what say, electrical field in the path of it, they will deflect from the path. They will deflect toward the side of positive terminal. That means they themselves carry negative charge. Only then it will be bending toward the positive side. So that is how we can say that cathode rays do carry negative charge, because they are behaving like negative charge particle by getting attracted toward the positive terminal. Similarly, if we do place the magnetic field as well, they are behaving just like the negative particle behaves. So this is how we can get to know that cathode rays do show the change in the presence of electric and magnetic field. Moving on to the next property of cathode ray, that they can cast the shadow of anything that is placed in the path of it. So this is just the anode metal cross just put inside it, okay, in that cathode ray tube, and the cathode ray tube anode metal cross, you can simply see the shadow of it backside to the anode portion. So this is the indication that yes, it show the property to cast the shadow as well. All right, moving on to the next property, that is heating effect. Okay, so when any metal piece is placed in the path of it, it will get heated up. That means we can say that it shows the property to heat the object that is present in the path of it. Moving on to, this is very important property. This is very important. As I told you that basically what comprises the cathode ray is electron. Right now, the electron will never ever change, whether the electron is of metal, whether the electron is of gas A, whether the electron is of gas B. Electron will not at all change. So we can simply say that the E by M is specific charge. The specific charge, beta, what is specific charge? Specific charge is E by M, charge by mass. All right, so charge by mass of cathode rays will not at all change. If we are changing the gas present inside the cathode ray tube, if we are changing the electrode of metal, it will not at all did any change on the specific charge. The charge by mass of the cathode rays will remain the same only. So this is the indication that yes, ma'am, we get to know that E by M of cathode rays will not change by the nature of gas, by the nature of electrode. It will be the same irrespective of the gas used in the tube. So this is very, very important point, because this thing will change for another type of ray, that is anode ray. Moving on to, they will produce as X-rays. See, this is a very unique property of production of X-rays. So whenever any cathode ray is falling on a heavy metal, this is cathode ray. This is cathode ray. If it is falling on a heavy metal, they will produce what? They will produce X-rays. So this is another property of it. Moving on to next property, that is the ionizing power. So we can say that ionizing power, what is the meaning of this? That cathode rays are having the huge tendency of showing the ionizing power. Right now I told you that cathode rays can easily ionize the other gas as well, right? So this is another property. Moving on to next point, that is that cathode ray produces Okay. Cathode ray produces scintillation. Scintillation is what? It is basically a bright spot production. Okay. On the photographic fluids, they can produce the bright spot. Moving on to next point, they can show the penetration. That means if we do have any metal sheet, they can easily penetrate. Penetrate means they can move inside that metal sheet. In the metal sheet, it can easily penetrate. So these all are the points, properties of cathode rays. You can list them all there in your notebook. Very important points regarding cathode rays. Any problem? Samarth, very good. Yes, charge by ratio. Online class. How was going on? Online class is going on fab, beta. You can tell me that how the online class is going, right? That is the question I have to ask from you. All right. So this is the 11 properties of the cathode rays that we have discussed so far. Now there is application as well of cathode rays, like how we can say that cathode rays do apply that in our daily life, right? So first properties of TV picture screen. The television picture screen that you all can see is what? It is basically due to fluorescence of television screen that is coated with a suitable material. There as well, cathode ray tubes are there that continuously produce the fluorescence, and accordingly you see the color of it, right? Moving on to the fluorescent light tubes. That fluorescent light tubes are also doing the same thing. They are also what? They are also cathode rays only, and that is producing the light. So these are the application of it. Okay, fine. These are all the properties and application of cathode rays that we did so far. Now moving on to the Thomson experiment. What is Thomson experiment, ma'am? See, E by M, that is charge by mass, that is specific charge, that comes out to be this much of cathode rays, that is electrons, right? So who proved the value of E by M to be this? What is the value? What is the specific charge? So this is the value that was calculated from the experiment conducted by Thomson. Now what is the ma'am, why cathode? Negative cathode. But a cathode, basically cathode is that electrode. Cathode is that electrode that is, what it is doing. The negative charge production is from the cathode portion, right? The negative charge are producing there from the cathode portion. That is why it is termed as the negative portion, the negative electrode that is connected with the negative terminal of the battery, that is responsible for the production of negative charges. Okay, fine. That basically attract the cation. Cathode is basically itself negative. Attract what? Cation. Cation are what? Positive charge particle. That is why we are terming it, we are signifying the symbol negative over it, because it is attracting cation. Cation is the positive part. All right. So this is how we can easily use the symbol accordingly. Okay. Moving on to here, the basic setup of Thomson model, where the same experimental setup is there. Anode is present over here, and even over the anode, we can do the small perforation. From this hole, the rays pass straightly, right? In the absence of many magnetic field and electric field, the both fields over here are absent, beta. The both fields over here are absent. All right. Right now we are for say not applying any electrical magnetic field. They will parallelly move straight only. Now if we do apply any electrical magnetic field, what will happen? Accordingly, the line will deflect from its path either to point A or point C, depending on which field we are applying. If we are applying, let's say, electrical field to the positive terminal, it will start to bend. We will get the point A over here, the dot to the point A, right? Accordingly, if the magnetic field is applied, it will be striking to this photographic plate to the point C, right? And if we are balancing them both, we are getting the point B. If we are balancing the both, we are getting it to the point B. So by the experimental calculation, the angle of deviation, and we are all calculating the E by M, that is coming out to be this much. Okay, so you all have to learn the E by M, charge by mass of electron, right everyone? Clear everyone? Fine everyone? Yes. Fine. So the deflection will depend on what factors? It will depend on the charge of electron. It will depend on the mass of electron. Higher the charge, higher the deflection. Higher the mass, lesser the deflection. Higher the electrical and magnetic field, higher the deflection. So it will depend on deflection. Deflection will depend on what factor? The charge increase, deflection increase. The mass increase, deflection decrease. The electric field and magnetic field If it increases, the deflection will accordingly increase. So these all are the factors on which the deflection of the we can say cathode ray depends, right? Okay, moving on to another experiment, Millikan oil drop experiment. In this experiment, basically what is the thing that we calculated? We calculated the charge on the electron. You all have to know that what is the experiment used for to determine either the EFIM, that is Sobson model, to determine the charge, that is Millikan oil drop experiment. So in this experiment, what basically happen over here is, let us discuss it as well. So we over here are these having these two charged plates. What we are doing, this is the atomizer, students. This is the atomizer that contains oil in it. So just spray this oil with a very fine mist, we can say. The oil spreads uniformly over here. Through this pore, the oil will start to flow, right? Over here we are passing the X-rays. What is the function of these X-rays? X-ray will produce, it will ionize the gas that is present. It will ionize the gas that is present. For say like this. All right. So X-rays are having the tendency to ionize the gas. So here many gases are present. The gases will ionize themselves and produce the electrons accordingly, right? Now, if the electrons are produced, these electron will come to the surface of this oil. Which oil? This oil. Oil is not carrying any charge initially, but due to the we can say connection there with electrons, it will develop a charge, because electron will attach itself to the oil surface. So thereby we can say a charge will develop on oil, and that is a negative charge. Now, two types of forces arises. One is the force that is due to gravity. It will be flowing downside, but other is due to the electrostatic attraction from the positive charge plate, that it is moving toward upside. Overall, that is visualized from this telescope, and accordingly the rate of flow is calculated. And from all these experiments, there is no as such calculation. You just have to learn the charge on electron, that will come out to be 1.6 into 10 raised to the power minus 19 coulomb. That is it. Okay. Yes, beta. Ma'am, PW subscribe batch, what are the portions covered, completed in chapter wise? Please tell. I am willing to join the batch. Okay. Okay. So one student is asking about the batch, although yes, we have already started the batches. The batches are also already done. Right now, currently we are for Arjuna NEET. I can tell you the planner, and you can easily visit the platform, beta. Just download the app, or there in the description as well, you can get the link where the batches are going on, and you can easily see the syllabus going on over there, and the completed and the upcoming portion. You can access all the features over there only and get the idea about it. Okay, fine, beta. All right, moving on to these all other terms, that the charge of electron is this much from the Millikan oil drop experiment, the E by M from the Thomson model of an element, and then moving on to that mass. Mass is how much? This is the mass on an electron, 9.1 in 10 raised to the minus 31 kg. This is the mass on an electron, that is approximate 1 upon 187th time of that of hydrogen atom. So all these observations simply indicate the properties of the electron that are discovered from the cathode ray experiment, right? So here we are having this another point, that Q is equals to Ne. What is the meaning of it? It is basically quantization of charge. Quantization of charge. What is meaning of it? Quantization of charge. What is the meaning of it? That we have this oil, and the oil will develop a charge depending on how many electron it will strike with, right? So 1 electron, that means overall charge developed by the oil is 1 times of electronic charge, 2 times of electronic charge, 3 times of electronic charge. So net charge developed by a particle is equal to n times of the charge of electron. All right, so this is the basic formula that you might have studied then in your lower classes as well. Moving on to the same experimental setup, that is very good. Charandeep, very good, very nice beta. For all the students who didn't like the session so far, please just click that like button so as to mark your attendance, because that is a required thing before you start your session, right? Okay, then is the discovery of proton. See, before the discovery of any other, we can say right now we did discuss about the discovery of cathode, right? Cathode rays we already have covered, that is electron discovery. Now moving on to anode. rays discovery. Anode rays are also known as we can say canal rays or positive rays or anode rays. So all are the name for one and only same thing only, that is the positive charged particles rays, right? Just similar to the negative charged particle, they are also behaving or showing the results of the previous experiment that we did. Now just only difference is there, we can say they differ from this because of the sign. So they are showing some changes in the directions, right? That means over here they are produced from anode and moving toward the cathode terminal, right? So this is the first point, that they are traveling straight just like the cathode rays. When we can say cast the shadow just similar to the cathode rays, deflected by electrical and magnetic field just similar to cathode rays. Now the only difference is the deflection, we can say direction is opposite just to cathode, right? Okay, clear? Yes, just opposite to what? Just opposite to the cathode rays that we did so far. So the behavior is just opposite in direction to that of anode rays. Rotate, again they are also rotating the wheel just like the previous case. Here this is the point, the charge to mass ratio, it is smaller than the electrons, very important point. But unlike the cathode rays that we did so far, they are not depending on the nature of gas and electrode. But here we do have anode rays, they will be changing their specific charge, that is charge to mass, if the gas is changed, right? If the gas is changed, why is it so, ma'am? Because students, if the let's say A2 gas is there, so A2 gas will ionize itself, right? A2 gas, let's say this will ionize itself, this is the electron of gas that is produced over here. Similarly for say B2 gas, B2 gas is again ionizing and producing the electron of this B2 gas. So over here we can simply see that this is the positive charges of the gas that we are getting. These are basically the anode rays. So if the gas is changed, the positive part will change. Accordingly, the nature will be changing of specific charge, that is charge to mass. Is that clear to you? So beta, this is very important point, that depending on the gas, if we do change the gas, that means the nature will also change. We are changing the gas, again the color will also change, because yes, anode rays do get affected by the nature of the gas, because they are produced by the gas itself, right everyone? Okay, about NEET NEET 2027, beta, whatever questions or queries you do have about the batches, what you can do is just download the app. There in the description as well, information about the batch is given to you. You can click on that, you can go to the link, you can accordingly see what are the features of the batch and how many chapters are already completed and how many chapters are yet to come. Okay, the ongoing chapter as well, all the important information you will get to know from that only. Okay, so go to the what you can say the platform, and accordingly whatever batch you are asking about, okay, you can get to know the information about it. Okay, fine everyone. So these are the properties of the anode rays. Okay, moving on to the final conclusion, the charge similar to that of electron, just the difference is it is in positive unit, right? Mass comes out to be this much, and E by m, that is maximum for hydrogen, because my hydrogen gas mass is minimum, so that is why we are getting the E by m to be maximum. How much? 9.8 × 10⁻⁷ coulomb per kg. So these all are the values. Moving on to the next, because these are the theoretical portions, so we are wrapping it up with a more we can say faster rate, because these are the theory portions, right? Okay, moving on to the radioactivity concept. Beta, okay, before that we are discussing about the X-ray concept. Okay, X-ray concept. What is this X-ray concept? So William Rontgen, what he showed that when we are striking the material on a material with cathode rays, it will produce what? It will produce some rays. We are unaware about the name of it. So by suppose, let us say, we can say it to be as X-ray. Okay, so right now as well we are naming it as X only. Okay, in mathematics what we do usually use now, that suppose let it to be X, any unknown value is considered to be X. On a similar basis, the rays that are produced by the, we can say, striking of cathode rays over to the material, right? So we are naming it as, let us suppose it to be X, and right now as well we are naming it as X-ray only, right? Okay, fine. So this is how we are getting the X-rays. And what are the properties of these rays? X-rays are basically not deflected by electrical and magnetic. Okay, they are very high They are showing very high penetration power, having very shorter wavelength. Okay, and they do produce electromagnetic characters, electromagnetic properties. What is electromagnetic, ma'am? Now we will discuss that in the upcoming portion, that what is electromagnetic component, what is electromagnetic properties. We will do discuss about all of these in the upcoming portion, right? Okay, fine. Moving on to the concept of radioactivity. You have to know the name of the scientist, that is Henry Becquerel. It is given there in your NCERT. So that is what I have covered in few minute, you can say, portions. Okay. Henry Becquerel is a scientist who have discovered about the concept of radioactivity, that certain materials have the capacity to produce the radiations out of it. So he named them as radioactive elements, or the radiation that is produced from that are radioactive, we can say, radiations. Okay. Yes. So this is about the concept of radioactivity. So in physics, this portion will be covered in much more detail about the alpha rays, about the beta rays, about the gamma rays. So what are these? What are the behavior of it? So these all are the portion that will be covered there in your physics portion. Okay. Fine, beta. X-ray. X-ray is what? X-ray are the positive charge rays, we can say, that are developed due to the, we can say, striking of cathode ray to any particle, right? Positive, not X-ray as just the, we can say, production of the gases. See, if there is a material, over to the material, these are the cathode rays that strike over to the material, and when the cathode rays strike to the material, some certain rays are produced. Okay, certain rays are produced. Now what are these? What is their properties? I have listed them all in the previous slide, right? So these are beta X-rays that are produced by the striking of cathode rays over to the material. Why is it? Okay, why is it X? Just like in a random, we can say, let us suppose the unknown factor to be X, right? Na? So on a similar basis, here as well, the scientist named it as X because he was unaware about the nature, unaware about the gas. So he just assumed it to be X. He just assumed it to be X. Okay. Fine. Okay, moving on to the next discovery, that is neutron discovery. So James Chadwick did the discovery by just striking the helium. Beta, what is helium? Helium is your alpha particle, two positive, carries the two positive charge. So just pass the helium alpha particle there to beryllium. When he strike this alpha particle to beryllium, it is causing the production of this neutron along with the carbon formation. This is the neutron discovery because it is neutral. So it was discovered much after the discoveries of electron and proton. So it overall carries no electrical charge. It is neutral and produced by the reaction of beryllium with the alpha particle. So this is about the neutron discovery. Fine, beta. Clear? Is that clear to you all? Yes or no? So this is about the summary of all the fundamental subatomic particles, that is electron, proton, neutron. These are the masses in kilograms. You all have to revise it very thoroughly. Then moving on to the relative masses, comparable masses. So we can say that 1, and approximate this mass is 0 over here. So these are the relative masses, right? Moving on to the charges that they do carry. Beta, this is just the opposite in sign charges of electron and proton. The magnitude is same only, and the neutron do carries a neutral, that is net 0 charge. Okay, and if we do relate themselves, so this is the relative charges and these are the actual charges there in column, and these are the relative charges. Electron to be -1, proton to be +1, and neutron carries 0 overall charge. So these are the overall, we can say, charges. Moving on to the E by M value. So now how to compare, ma'am, E by M? You just have to put the values. You just have to put the values of E by M of electron, proton, neutron, and whatever the gas given there to you, whatever the ionic part given to you, you can easily calculate them out. For example, E by M, the charge by mass for electron comes out to be how much? The charge electron carries is -1.6 into 10 raised to the power -19 column. The mass that this electron carries is 9.1 into 10 raised to the power -31 kg. So this is the mass, this is the charge, right? Moving on to the proton. Beta, proton do carries the charge of the same magnitude but with a different sign. The mass that it contained is 1.67 in 10 raised to -27 kg, right? This is the charge by mass of proton. Neutron carries 0 overall charge. So the value E by m 1.67 in 10 raised to minus 27 kg. So it will come out to be 0 only. If they are asking about alpha particle force, so what is the alpha particle over here? Basically, these are helium-2 positive nuclei, right? These are your alpha particles. So if you calculate the E by m for the alpha particle, that is helium-2 positive, what it will come out to be? See, over here, the charge on helium is 2 positive. That means 2 into 1.6 into 10 raised to minus 19 column. And the mass on the helium particle is 4 AMU. And if you want to convert AMU to kilograms, how to do so? Just have to multiply 1.67 10 raised to minus 27 kg. AMU can be easily converted by to kilogram unit by just this simple mere conversions, right? So this is how you are getting any guess. For say they are asking about lithium-2 positive. Lithium-2 positive. How to solve it for lithium-2 positive, right? Lithium positive. If they are asking about lithium positive. Now how to solve it for lithium positive? How to solve it for lithium positive? मैम मेरे ऐप पर ऑनलाइन क्लास नहीं चल रहा है, उस पर एक्सेस टेम्पोरली ब्लॉक्ड ड्यू टू अकाउंट एक्टिविटी. ओके बेटा, you can use the option of support over there only. आप सपोर्ट ऑप्शन को ऑप्ट करिए एंड thereby you can get to know that क्या सही है क्या नहीं है. ठीक है, अगर ऐसा कुछ दिखा रहा है टेम्पोरली ब्लॉक्ड एंड एनीथिंग लाइक दैट, यू जस्ट हैव टू गो टू द सपोर्ट ऑप्शन and accordingly raise your concern. Okay beta, fine. So okay, moving on to this electron charge by mass. So positive charge E by m, if it is having plus 1 charge, so just write it at 1.6 in 10 raised to minus 19. And mass of lithium, what is the mass of lithium? 7U, right? So 7U AMU, just have to convert to kilogram terms like this. So thereby you can easily put the values accordingly. Any question given to you, you can easily find it out. Okay, let's move to this question now. Let me see that how many of you are answering the question. E by m value is least 4. If you are asking about the least value of E by m, what is the final answer you are getting beta? E by m is least value. So if I ask you about the deuterium, right? Deuterium do contain, what is the mass number of deuterium? It is 2 plus 1. So that means E by m is what? It is plus 1 electronic charge, that is 1.6 in 10 raised to minus 19 column, and the mass of it is 2U. 2U, that means 2 into 1.67 in 10 raised to minus 27, right? Kilograms. So this is the E by m of deuterium. For lithium 2 positive, so 2 positive, that means 2 times of that electronic charge, and mass value comes out to be 7 AMU minus 7 into 1.67 10 raised to minus 27 kilograms, right? Like this. Alpha particle is what? Right now I told you about the helium-2 positive nuclei. So just have to put the value. Charge is 2 twice, that is 2 into 1.67 in 10 raised to minus 19. And what is the mass of it? 4U, that is 4 into 1.67 in 10 raised to minus 27 kg. Right, so this is the E by m values of alpha particle. Accordingly, for proton, E by m comes out to be 1.6 in 10 raised to minus 19, that the electronic charge, and the m value comes out to be over here 1.67 in 10 raised to minus 27 kg. So accordingly, you just have to compare them all out. Electron, beta, just have a look. In the previous portion as well as I told you that electron, what is the E by m least for or max for? So if I do ask you about the maximum E by m, see, the electron do carry the least value of mass. So E by m is max for electron. Then comes your which category? Have a look. Then comes your which category? Depending on what the value you all are getting. Since neutron carries 0, right? Neutron do carries 0 E by m. So neutron is coming least value E by m, right? The subatomic particle among electron, proton, neutron, which among the three do carry the least E by m. So it is neutron, and proton to be the central one. If I do ask you about alpha particle, then what is the alpha particle position among them? So alpha particle do carries 1 by 2 times of proton, right? 1 by 2 times of proton. So alpha particle is far behind the proton value, right? Far behind the proton value. But we can say that electron proton, alpha, neutron. Then moving on to lithium positive. Lithium positive. Lithium positive is 1 by 7 times. That means much more less than, we can say, alpha particle. Lithium 2 positive is having what? Lithium 2 positive, if we are having lithium 2 positive force. So here we do have the electronic charge of this much. It will come out to be 1 upon 3.5 times of that proton E by m, right? So we can say that 1 upon 3.5 and electron is 1 by 2. So lithium 2 positive is much less E by m valued as compared to electron. So I can write over your lithium and then your neutron value. So this is how we can easily write about any such type of questions, that if they are asking about the comparison about the E by m values of different type of we can say species, we can easily find them out, right? Okay, option number 4 you all are getting. E by m is least. E by m is least. Beta see, E by m is least. They are asking you about E by m least valued. Have a look. If I do talk about the lithium, all of them do carries this factor as the common term, right or not? This factor as the common term. Although I have written that, but there is no as such need for you guys to write them there in your examination. You just have to see that this is the common term that is common in all of them. Right now we are having this to be 1 by 2, 1 by 3.5 and 1 by 2, right? So this is 1 by 2, this is 1 by 3.5, this is 1 by 2, and this is complete one value, single valued. So the one that contain least value is the one that contain the max denominator, that is maximum denominator will get the minimum value. It will come out therefore lithium 2 positive, right? So this is how you all have to solve it all out. Okay, the least value is the one that is minimum numbered, right? So this is the equation. Similarly, if specific charge of A2 positive is given to you, then you have to find out the mass. Now, what is the question asking about A2 positive? So, E by m comes out to be how much? 2 times of electronic charge. So, 2 times of 1.6 and 10 raised to power minus 19. And the mass, we are unaware about the mass. Mass is asked there in our question. And the specific charge given to you is how much? 4 into 10 raised to power minus 5 coulomb per kg. So this is the formula that I have created over here, and accordingly you have to find out the value of m. Simple, as simple. Yes, option 2. Yes. Ankur, very good. You are getting the correct option only. So this is how you all have to solve that, whether they are asking you about A2 positive, 3 positive, 4 positive, whatever ABC thing is given there to you, you just have to accordingly substitute the value and you have to find the answer according to the question they are asking about. Okay, okay, fine. Okay, all right. Then moving on to next portion, that is fine. This is the question I'm asking from you guys. Just do let me know in the comment section whether you know the answer or not. The specific charge of electron depends on. The specific charge of electron depends on. It will depends on. Okay, one second. There is something fishy. Something fishy. Something fishy. Ruko. Okay, the previous question. Gas nature, potential difference, electrode, or is it universal constant? Specific charge of electron depends on either the gas nature, either the potential difference, either the electrode, or is it universal constant? Tell me the answer then in the chat section. Okay, beta. Tell me the answer then in the chat section what you guys are getting the answer to be. Whether that is gas nature, potential difference, electrode, or is it universal constant? All right. So, okay. Hello, welcome everyone. Okay, so charge, specific charge. See beta, specific charge is irrespective of the gas nature. Let me make you very clear. I've already covered the concept in the previous portion that gas nature will not at all impart any change to charge, specific charge. Okay, so it will not be there. Potential difference again will not impart any change to the charge by mass, although it will fasten up the process of cathode ray emission. Otherwise it will not at all do any change for specific charge. The charge will not change, the mass will not change. Electron again will not impart any change to the cathode rays, the electrons. It will be always universal constant, and I already told you the value. But it is option number 4th. Right now I told you, explained you the concept in the previous slides only. Okay, option 4th will be your answer. The specific charge of canal rays will depend on the gas nature, Next question. Specific charge of canal rays. Canal rays, that means anode rays, those positive charge rays. Okay, so here you have to see that whether it will depend on gas nature, potential difference, electrode, yeah, all of these. Tell me. Here it is, yes. It is for canal rays. Canal rays are always dependent on the gas nature. So that is why you're getting option first to be your correct answer. Okay, fine, fine, fine. Yes, gas nature. Okay, fine. Moving on to next concept now. Beta, what is, let's say this is the question of electron count, we can say. In the previous chapter, backlog coverage, we have already covered the topic about the subatomic particle calculations, the electron, proton, neutron calculation. So here's a question. Just try this question, all of you, that if we are having X3 positive ions which contain 18 electron with mass number given to you, find Z. Z is what? Z is atomic number. Better do let me know in the comment section that what is the answer that you all are getting. We'll see that whether you are familiar with the concept or not. Atomic number you have to calculate for the species that is X3 positive do contain electron count to be 18. So if X3 positive, X3 negative do contain 18 electron, so what is the electron count of the neutral species? Because if somebody is having a negative charge, that means it have already gained that electron. If 3 negative is there, that means 3 electrons are gained, right? So overall, the neutral species must be having the electron number to be 18 minus 3, that is 15 electron count is there. That is 15 electron count, because this species gained 3 electron, that is why it is getting that 18 number, right? And this is the electron count, and accordingly neutral species proton and electron count are always equally number, that means it is also 15. So atomic number will come out to be equal to proton number, that is 15 only. So this is how you have to answer the question. If they are asking about the neutron number, you can easily find that neutron number as well by subtracting a minus z. A is 31 and it is 15 over here, right? Clear everyone? So you're getting the number out to be 16. So this is how you have to solve this question. Yes, very nice, very simple question it was. Yes, absolutely right. Okay, fine, 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 fine. This is another type of question, another variety of question. The mass of electron is half. Mass of electron, whatever the mass of electron, okay, species given to you is oxygen 16. Beta, see this type of question, it is again a very good question. Very good question it is. Let us discuss about the question. See, we do have a species oxygen 16. Oxygen 16, right? Yes, ma'am. Here it is given to you that if we do have oxygen 16, the electron in oxygen 16 is 16. The proton in oxygen 16 is 16. And, electron over here are how much equal to the atomic number, that is 8. Proton is also 8. And about the neutron, you just have to look on to the mass number minus atomic number. 16 minus 8, that is 8 only. Now in the question they are giving you, let the mass of electron is half. That means to a new species, let the mass of electron is half times of the original one, that means 4, right? Mass of proton is 2 times, that means it is twice of the original one, coming out to be 16 in number. And the mass of neutron is 3/4 of original, that means 3/4 of original is 8. So we are getting the number to be 6, right? So this is the new quantities that we are getting of the newly developed species according to the question. Then find out the new atomic weight of oxygen 16. What is the new atomic weight? Beta, atomic weight is just simply by the mass number of the new developed species. Mass number comes out to be proton plus neutron. So proton is coming out to be how much? 16. And neutron is coming out to be how much? 6. So overall we are getting the number to be 22. Now how the percentage change we can simply see over here. So percentage change is the change that we are getting in mass upon the original, the initial one, the original into 100. So this is the formula that we can apply to find out the percentage change. So the change in mass number is 22 minus the original one. But was the original one? Original mass was 16. 8 plus 8, that is 16 only. So 22 minus 16 upon the original into 100. This will be the change in the mass. How much change you are getting? So yes, very nice, genius. Beta, you are absolutely right that it will definitely gonna increase by 37.5%. This is the absolutely correct answer by solving the term over here, right? This is how you have to solve it out. Okay, fine, 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 fine. Okay, moving on to the next concept of average atomic mass. Here we are taking the average. In your lower classes, you have studied the chlorine mass number to be how much? 35.5. But in reality, if I ask you that whether the chlorine contains 35.5 mass number, you will say, yes, ma'am, we have learnt it in our lower classes that chlorine is having 35.5 atomic mass number, right? But this is not the final result. Nothing like chlorine at all exists with mass number 35.5. That is the average mass number that you usually use, right? So there is average concept. What is the average concept? That we do have different isotopes. Isotopes do have different mass number. Mass number is different. Mass number is different, but the atomic number is same. Atomic number is same. So in that scenario, we do use the term average of it. Like chlorine having 35 mass number and chlorine having 37 mass number. Okay, but here both the chlorine isotopes are occurring differently in the nature with a percentage of 75 of this chlorine and 25% abundance of this isotope of chlorine. So average of their atomic mass is taken, that to be equal to mass number, that is 35, into the percentage, that is 75%. Similarly, the mass number of the second isotope into the percentage of it, that is 25%, like this. On solving it out, you will get it out with 35.5. So this is the average mass that you usually use. It is not the actual mass of chlorine. Nothing at all 35.5 chlorine exists there in nature. It is just the average that you all are using over here. All right. Okay, fine, 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 fine. So let's try this question. Naturally occurring boron has two isotopes. Fine. One with atomic weight of 10 and another we know 11. Means boron having mass number 10 and boron having mass number 11. Atomic weight of naturally bromine means they are taking the average of it. Atomic weight of natural bromine is 10.8. This is the average. The percentage of isotope first and second you have to tell it. Okay. Average mass will come out to be how much? Average given to you, that is 10 point. Average mass number. Average mass number. Mass number given to you. How much? 10.8. That is equal to the mass number of the first isotope, that is 10, into the percentage. We are unaware about the percent, so let us suppose it to be x%. X by 100, right? And adding up with the second one, that is 11 mass number, and the percentage of it will come out to be 100 minus x then. 100 minus x then. 100 minus x then. This is the percentage of the second isotope, right everyone? On solving it out, what is the value you are getting it for x? You just have to simply check it out. You just have to solve this out, and the x you have to determine, that is the percentage of first isotope of boron, and accordingly subtracting it with 100, you will get out the second isotope's percentage. And the final answer, what is the final answer you all are getting? Beta, what is the final answer you all are getting? What is the final answer you all are getting? Okay, so let me make you very clear. It is the first option, 20 and 80% accordingly. Okay, fine. And there are many much type of question. I'm giving this question as a homework question to all of you guys. Just try this question and do let me know in the chat section what is the answer that you are getting for this question. Okay, in the chat section you have to tell me that what is the answer you all are getting for the question. Okay, moving on to the next models, that is the Thomson model, the prior model, the first model that we have discussed for atom, that is J.J. Thomson model, resin pudding model, where it is compared with the watermelon or raisin or plum pudding. This is the positive charge particle, positive sphere. This is the positive sphere. Over to this positive sphere is the negative. We can say over to the positive sphere there is the negative points of electrons, negative particles of electron, just like the seeds present inside the watermelon. The reddish part of the edible reddish part of the watermelon is the positive part, and the seeds that is embedded inside is the negative particle, that is electron. So this is the distribution of the charges in the model that is given by Thomson, but that was actually not acceptable, because according to the model, radius was estimated that is equal to the size of atom, that is 10 raised to minus 10 meter. But this is having certain drawbacks. right? How that electrons proton be stationary? We all know that electrons are moving inside the atom, so this is not acceptable that electron is stationary, but we know that electron are moving in an atom, right? After neutron discovery, because in the model only electron proton was discussed, nothing about neutron at all were discussed, right? So this is the exception, the drawbacks of the model. Moving on to the next model beta, that is Rutherford model. Rutherford, although giving a very good explanation about the planetary model only, where a gold foil was taken, over to that gold foil alpha particles, that is helium 2 positive nuclei, so just passed, bombarded over to the gold foil, where we can say that what were the observations of the model, because this is gold foil, over to the gold foil alpha particles was just, you know, striking over it. Now here we do have this detecting screen that detects and updates, give the information about the rays striking over the screen at which angle, right? That means this is the we can say detector portion, all right, because although the rays are not at all visible by, right? Okay, hello, welcome students, whosoever is joining our class, just clearly listen to me. What I'm telling to you is a Rutherford model. In that model there is certain we can say observations. What were the observation? That the majority of rays passes straight without any deflections. Certain rays bended with small angles from the original path. Few rays bended with a large deflection, and very few, although you can say 1 out of 20,000 ray, let's say, retraces its path. Means the one that comes like this and again go back like that same path only. Okay, so these were the observations. This is how we can simply show it out, that this is the gold foil, that the particles like atoms are present like this, where the rays were passed like this, majority rays passes undeflectedly, small deflections, large deflections, and there is a back scattering that is very less in number, right? Very less in number. So this is the observation of the Rutherford model of an atom. But after the observation, there were some conclusions drawn. What were the conclusions? Let us discuss them all. So the first conclusion was the discovery about the nucleus, that something is present at the central portion of an atom, because if the alpha particle rays, if the alpha particle rays just strike there with the atom, just strike there with the atom, alpha particles themselves carry positive charge. Alpha particles themselves carry the positive charge, because they are what? They are basically helium 2 positive nuclei. So if alpha particles do carry a positive charge, right? How they carry a positive, like how the nucleus carries a positive charge? Because when the alpha particles rays strike that atom, they rebounded. Something central portion contain a very heavy part that is rebounding the path of alpha rays. It makes the clarity that something heavy is present inside the atom, having a huge mass as compared to rest of the atom, and which contain a positive charge that repel the upcoming alpha particles, right? It will repel the positive charge particles, you know, that is striking over to it. So this is the discovery about nucleus portion in the atom. Moving on to the another conclusion, that is the electrostatic force of attraction present between the nucleus and the electrons that are revolving around it. Then moving on to the empty space concept, that means majority rays passes undeflectedly. That means the majority space is empty. That is why majority rays were able to pass through the gold foil. Okay, so we are considering the atom to be majorly empty. That is the reason alpha rays passes undeflectedly. Moving on to the radius conclusion, that the radius of atom is approximately 10 raised to the minus 10 meter, and that of nucleus is minus 15 meter. Okay, then moving on to the, accordingly we can see the diameter density as well. Accordingly we can see the density as well, that what is the density that we all are getting. Ma'am, in nucleus, proton and neutron is present. That is why it is positive. Yes, obviously, beta. Charandeep, obviously. Yes. That in nucleus, proton, that is positively charged subatomic particle is present. That is why nucleus is overall carrying a positive charge, right? Okay, fine. Then moving on to another concept. One second. Okay, fine. Okay, these were all the conclusions. So this is another the concept of the density term, the volume term. If you want to do relate the volume, let's say you know the volume of atom by volume of nucleus. So volume is 4 by 3 pi r cube. The radius of atom is how much? 10 raised to the power. See, there is a radius conclusion from the volume term relation. Okay, so we can say that the radius of atom is 10 raised to the minus 10. We can take the cube of it, 4 by 3 pi r cube minus 15 cube. So thereby we can easily solve it out. 10 raised to the power plus 5, that is, we are just taking the volume relations from the radius relation. We are considering the atom and nucleus to be spherical. So if I want to relate the volume terms, I am just taking what beta? I am just taking the relation just similar to the formula of radius of or volume radius of an atom, radius of the volume in terms of their radius of an atom, radius of the nucleus in terms of their volume, by to be 4 by 3 pi r cube. Okay, so coming out to be 10 raised to the power 5 and taking the cube of it, coming out to be 10 raised to the power 15. So this is how we are solving it all out. Okay, is it clear beta? Is it clear? Is it clear? Nucleons are what beta? Nucleons are the combination of the nucleus and neutron and proton that together comprises the nucleons. Okay, fine. So this is about the volume relation, and opposite to volume is the density relation, because we don't know that density is equals to mass by volume. So just reciprocating the atom and nucleus volume, we are getting the density relation to be like this. Fine. To the 10 raised to the minus 15 term of density of nucleus. Moving on to the radius of nucleus. Radius of nucleus. Radius of nucleus. So this is the radius of nucleus, coming out to be proportional to the mass number. This is the mass number. This is the mass number. Taking the cube root of it, and we are getting what? We are getting the ratio of the mass number with the nucleus radius. Right? If we are removing this proportionality sign, we are getting R naught. We are getting R naught, and R naught is what? R naught is a constant, coming out to be this value only. Fine? Clear? Clear, clear, clear? Fine. Any doubt so far, you can ask beta. If you're having any doubt, you can ask. Now comes the exceptions, the drawbacks. Majorly the drawbacks. What are the drawbacks of this model? So first drawback is the stability of an atom. How come the electron that is revolving around the nucleus is stabilized, right? So this is the first drawback, that if the electron is revolving around the nucleus in a circular motion, we know that circular motion is uniformly accelerated motion. If the electron is revolving around it, according to Maxwell concept, if a charged particle is moving, so obviously it is undergoing the accelerated motion. If it is undergoing the accelerated motion, it is continuously releasing the energy. It is continuously releasing the energy. If the energy is continuously releasing, then that means electron will ultimately reduces its energy. It will decrease its energy, and ultimately due to opposite charge, electron do carry negative charge, nucleus carries positive charge. They both will collapse there with each other. That means it will take rough approximate 10 raised to the minus 8 second for an atom to get destroyed, right? So it seems like all the things you are seeing around you are just bursting out, because all of things are comprising of atom only. But it is not actual case. Electrons or atoms that in the nucleus are stabilized only. That was explained by Bohr model. So Rutherford model do not explain the stability concept. Moving on to the concept that if the electron is emitting the radiation continuously, so the spectrum that we are getting should be continuous, but the line spectrum is discontinuous. Right? How the electron structure of in the atom do exist, like how the electrons are distributed inside the atom, that all were not clarified there by Rutherford model of an atom. Okay, moving on to the next model, that is Bohr model. Now after Rutherford, there is no direct shift there to the Bohr model. There were numerous experiments going on, numerous theories going on. Then after that, Bohr model was established. But between that, there were two major developments. First one is the dual nature of the EM radiation. This is very important discussion. that radiations do contain electromagnetic properties. Then is the atomic spectrum. So these two were the developments that led to Bohr model, that make the Bohr model to be very much successful as compared to the Rutherford model. So let us discuss them one by one. First one is your Maxwell concept. First one is your Maxwell theory of electromagnetic radiations. So what is the concept? Basically defines us that we do have forces. This is the radiation direction. This is the radiation direction. This is the direction of propagation of a radiation, and perpendicular to it is the force electrical field component, and perpendicular to it is the magnetic field component. So these are three perpendicular directions: the direction of propagation, electrical field component, and the magnetic field component. All three are 90 to each other. So light is basically what? Light is a, we can say, EM wave. Light is an EM wave having perpendicular electrical field and magnetic field component. They are continuous, like a continuous. Light is a EM wave, right? So light is an EM wave. Radiation do have wave nature. They are behaving like a wave. So they are continuous. They don't require any medium to propagate. Different waves do have different frequencies, different wavelengths, different wavelengths, different frequencies. What is wavelength? What is frequency? We will discuss about it. According to this concept, energy frequencies are not having any relation according to this concept, but it was a failure, right? They do related with each other. We will discuss about it in upcoming portion, but these all were the postulates given by Maxwell in his theory. Energy will depend on intensity. What is intensity? How many rays falls on the unit surface area, right? So this is the intensity portion, that is the brightness of light. Then they travel with the speed of light. How much? 3 into 10 raised to the power 8 meter per second. So all of these were the Maxwell theory postulates given there. Okay. Moving on to, this is the spectrum. This is the spectrum given there in your NCERT as well. Basically, this is the complete electromagnetic spectrum, where we do have the different regions: gamma rays, X-rays, UV rays, IR, micro. So you can write it as CGX. You can write it as CGX, UV, IMR. That means CGX, UV, IMR. Cosmic, gamma, X-ray, UV ray, visible, IR, microwave and radio wave. Cosmic rays are not covered under it because they are having very high energy. So here we can say that moving from this portion to this portion, energy increases, frequency increases, lambda decreases. Accordingly, you can arrange the different regions depending on the question that they ask you for, right? This is very important. You all must have to remember the sequence along with the different measurements, all right? Because this can be asked in your question, that you have to arrange the different region according to their increasing frequency, according to their decreasing energy, according to their increasing wavelength. Accordingly, you have to learn the sequence, right? So these are the rays and their different functions. See beta, these are the functions of it. That gamma rays are used for what purpose? For medicine, killing cancer patients, right? And the X-rays are for body scanning, right? The UV rays absorbed by the skin can cause cancer as well, right? Mutant, it is a very good mutant. Visible rays can be easily visible to our eyes. Okay. Infrared IR rays transmit the heat from sun fires. Moving on to microwave, you can use for cooking, radars, TVs. Then moving on for radio waves. Radio waves are having their own applications for radio and televisions, right? So this is about the different rays, that there are different applications. Now moving on to very important topic, that what is the meaning of these different type of terms that we use for a wave. So this is the wave. The upper portion of the wave is what? It is crest. And the lower portion is what? Beta, it is trough. It is trough. It is trough. So the distance between, basically, we can discuss about the certain terms. The distance between two crests. This is the distance. This is the distance. This is the distance between two crests. This is what? This is wavelength. This is distance between the two crests. Two nearest crests is wavelength, represented by lambda symbol. This is lambda symbol. So this is length measurement. So basically the unit will come out to be in length term. Length can be either in picometer, nanometer, centimeter, fermimeter, angstrom. These all are the different units that we usually use there in a question. So tell me beta, if I do ask you about 1 nanometer will be equal to how many meters? How many meters? 1 angstrom is equal to how many meters? How many meters? Nanometer is -9, angstrom is -10, right? Fermimeter, picometer. Tell me there in the chat section. what is the unit relation between Fermi meter, or we can say Fermi meter and meter? Fermi meter and meter. Yes, it is very good to know that you are getting it all to be easy. EF is electrical field and MF is magnetic field. Okay, fine. Yes. So these are velocity. What is frequency? Firstly, frequency represented by nu. It is number of waves that pass through a particular point. On a particular point, how many waves are traveling in 1 second? So this is frequency taken as 1 by t. This is how we can take the frequency term, and its unit is hertz, or we can take it in time inverse unit as well. Time inverse unit as well. Reciprocal of time, we can take it in that unit as well. Second inverse, minute inverse, hours inverse, whatever the time inverse unit we can say. Also the frequency carries the formula. Frequency carries the formula c by lambda. C by lambda. Now c is what? C is the speed of light in vacuum. Okay. Velocity is what? Distance covered by the object, right, in unit time. Okay, similarly over here we are discussing about the wave. So how much distance a wave is covering in a unit time, that is your velocity. Time period, how much time a wave carries, how much time taken by wave to pass through a particular time, taken by wave to pass through a particular time. So time period is you do represented by T, capital T, and the unit is in time only, second, hertz, second, minutes, hour, depending on the units that we are taking of time only, right? Wave number is how many number of waves are present in single centimeter length, right? How many number of waves are present? So it is just the opposite of wavelength only. So we can use the term wave number. Amplitude is what? Amplitude is the distance of this wave, the height of the crest, or you can say the height of this trough. So these are the amplitudes of the wave, right? So this is very nice. Charandeep, 10 raised to the minus 15. Okay. Yes. Fermi. Yes. Fermi meter. Yes, absolutely. Okay, so these are the relations that we do use there in our question. Okay, so then moving on to the NEET 2021 question. Let us discuss this question. We'll see that how many of you are capable of solving it all out. So this is basically asked from your NEET NCERT book only. Okay, NCERT book only. So this is the NCERT question only that they asked there in your NEET examination of 2021. Particular station of All India Radio, New Delhi, broadcast on a frequency. So frequency given there to you, that is 1368 kilohertz. Kilohertz can be converted to hertz, right? So this is hertz. The wavelength of the electromagnetic radiation. So lambda is equal to what? Speed of light given there to you. So just have to simply put the formula. Lambda is equals to nu by c. C by nu. Lambda is equals to c by nu. 3 into 10 raised to the power 8 meter per second. And the frequency given there to you, 1368 into 10 raised to the power 3 hertz. And hertz is what? Hertz is second inverse. So you can simply cancel it all out and you can get the answer there of lambda in meter units only. So how much answer are you getting? How much answer are you getting? How much answer are you getting? So on solving, let me see that how many students have opened it up. Option number 2. Okay. Can I lock it? क्या इसको lock कर दिया जाए? Yes, Ankur. Whether to lock this option or not, we'll see that how many of you are answering that answer correctly. So simply you have to solve the formula. Just put the formula, apply the formula, and accordingly you are getting the final answer to be how much? You're getting to be the first option to be the correct option. First is your correct option, beta. Okay, solve this question and you are getting accordingly the first to be the correct answer. Just solve it out. Okay, fine. In meter you have to answer right now. Correct? Fine. All right. Moving on to. See, this is the NCERT question, and the similar question was just asked there in your NEET. So this is why I always told you that solving your NCERT is a mandatory thing for all the NEET aspirants. All right. So always solve your NCERT book because you can see that this is the NCERT question that was directly asked there in your NEET examination, right? Okay. So wavelength of light is this much. Calculate the frequency. How to solve this? Wavelength given to you 480 nanometer. You can accordingly convert the nanometer term to meter, right? So this is how you can convert the nanometer to meter. Calculate the frequency. So frequency is what? 3 into 10 raised to the power 8 by lambda. 480 into 10 raised to the power minus 9. So this is how you can easily find the frequency term. Okay, wave number. Wave number is how to calculate the wave number. Just reciprocate the lambda term. You can accordingly get the wave number. So 1 by this 480 into 10 is a minus 9. Accordingly, you can get the formula. I'm just showing you that how to solve these type of questions. Accordingly, you can calculate better by taking the approximations or many other methods. Just try to solve as much questions as you all can without using calculator, because calculator can, slow up your preparation. Okay, moving on to the drawbacks of the Maxwell theory, that this theory, limitation of EM wave theory, that they are considering the light radiation as wave nature only, but these are the phenomena that was not justified if we are taking the light as wave, just like black body radiation, photoelectric effect, line spectra, atom of atom with special reference to hydrogen, and then moving on to variation of heat capacity. Okay, so these four were the, we can say, main, that concept that utilizes the particle nature. If we are considering the light as particle nature, then only these all are justified. All right, so we can say that light do contain wave nature as well as these nature, that is particle nature. So particle nature we are discussing. Firstly, we are discussing the black body radiation. Black body radiation. Now, what is black body? You all are familiar with the term. Black body is an object, right, that is having the capacity. Ma'am, but doing calculation have so many silly mistakes. Yes, Ankur, you will find certain time, you will find certain question, you find many questions where you are doing just the calculation mistakes. But this is your preparation phase, beta. This is your preparation phase. Right now, you have to do max to max question as you can do by yourself without using calculator, because when you are getting the mistake there in a question, then you will realize that this is how I'm doing the mistake. That will not be repeated there in your NEET examination. Otherwise, if you don't do the practice portion, if you don't do the calculation portion, ultimately that will impact your NEET examination. That mistakes will definitely reflect on the NEET examination. So right now, in the preparation phase, you all have to solve as much questions as you all can. Okay, so here there is what black body do. What basically it is a complete absorber. It is a complete emitter. It can absorb the light of different frequencies. It can absorb the radiation, we can say, of different frequencies. It can emit, and it can absorb the radiation of all the wavelength on all the frequencies. Usually, a single object is having the capacity to absorb certain radiation only. It can never ever absorb all the radiation. It can absorb a particular light only, right? So particular wavelength light only. It cannot absorb all the radiation. So black body is such like thing that you can see over here with this example, right? You can see different colors. That means simply showing that different radiations are absorbed and they are emitted as well, right? So this is how a black body usually works, and it behave basically. How it behave. See, if the temperature, surrounding temperature, this is a black body. If the surrounding temperature is higher, exceeds of, if the surrounding temperature, this is the surrounding temperature and black body temperature. If the black body temperature exceeds the surrounding temperature, so ultimately black body will start releasing the radiation out. It's just like you can consider the black body as a hole, okay, that have no ending at all. So if the radiation enter, it will continuously move inside the black body only, but it will never come out. Okay, yes. Okay, one student is asking that, ma'am, when you give the formula separately, surely we can cover it as well. Yes. Yes, beta, you have to do maximum question practice beyond this, because I am covering all the concepts over here. So this is the graph of black body radiation. Now, what is the meaning of this? Beta, see, over here we do have the, what we can say, intensity versus wavelength graph. If I do heat iron rod is heated. So what basically it will do, if iron rod is heated, it will first change its color from dull red to bright red to, we can say, white to, we can say, blue. So this is how different color changes occur when we are heating an iron rod, right? So here as well, I'm just reflecting it out, that suppose this intensity versus wavelength graph at a particular T temperature, let us suppose it to be 3000 Kelvin. We are getting this graph. If I'm increasing the temperature, I'm getting this graph. If I'm again increasing the temperature, I'm getting this graph. If I am again increasing the temperature, I'm having these four different temperature graphs in a single graph only, right? Yes. Now you can see over here these points. What are these? These are maximas of their respective graphs, right beta? So if I'm getting this maxima peak, just have a look over it, that you can simply see that these maxima peaks are decreasing. If the temperature is increased, the maxima, this is lambda max, the maxima, this one is the lambda max, this is the lambda max, depending on which graph are you studying for, right? So you can simply see that the lambda max value is decreasing now, right everyone, depending on the temperature. So you can simply say, if we are increasing the temperature, all the intensity will be increased, but the lambda max will be decreased, right? So you can simply say that temperature, this is your NEET PYQ, temperature is inversely proportional to the lambda max value. I will show you the question as well, where in NEET this concept, I know many of the students are unaware about the concept. This concept was there in your NEET examination. Let me show you guys. This is the question. Have a look. Although this point statement question, they are in your NEET 2024 examination, they ask you about this question. I will not discuss right now about the statement first, because we have not covered the topic yet. But yes, just have a look about statement number second. When the temperature of black body increases, temperature increases, the maxima of the curve, the maxima, the maximum point, the peak point, intensity versus wavelength curve, right now I told you about, shifts towards the shorter wavelength. Obviously yes. Yes or no? Right now I told you about this or not? Tosif, welcome, very good evening. I'm good. How about you, beta? Okay. Is that point clear to you all or not? This was your NEET question, and the concept just arises from black body like this, that when the temperature of increases, then what happen actually? The temperature increases. Yes, correct option. Yes, very nice. Very nice. Immortal. Emperor. Place. Okay. Yes, both the statements are right only. But yes, right now I am discussing about the second statement, because that was our topic that we were discussing about. So this was about black body. The temperature of the black body start increases, becoming higher, surrounding and will decrease. Then these two were the examples. These two were the examples of the black body that is given there in your NCERT. Although no body at all is 100% black body, but here are we discussing about the idealized situation. Okay, so here is the situation, and these are the concept beta. As I told you, how the color will change about the iron rod when it is heated in the glass furnace, and this is the limitation about the classical mechanics. Classical mechanics do carry some limitation. It do carry some limitation that energy is absorbed or emitted continuously. So according to this concept, the energy depend upon intensity only, but not on wavelength or frequency. If wavelength or frequency are not having any change on intensity, the color will not change. But we know that color of iron rod is changing. So there is some limitation of this thing, limitation of classical theory. To overcome the limitation of classical theory, the theory of Planck quantum arises. Now we will discuss about the next theory, that is of Planck's quantum theory. Now what the theory basically states us, just like we can say the tap of water. One tap of water is flowing the water like this, dropwise, dropwise, dropwise. Another tap is just flowing the water this continuous manner, right? In this continuous manner, right? In this continuous manner, right? So this is discontinuous, dropwise, and this is continuous water flow. This is continuous water flow. So there are two types of water flow that we are discussing, continuous and discontinuous. Priorly, it was considered, according to classical theory, that the radiations passes continuously, right? But this Planck's theory denies it. It stated that the radiation do travel in the form of these packets, the crisp packets, that is known as quanta. So basically, the packets of energy is quanta. So these packets of energy, E is equal to, is proportional to, we can say, frequency. E proportional to, E is related to frequency. That was not given by Maxwell, remember? Here he told that energy and frequency are directly related with each other, and if I do remove the proportionality sign, I will get the constant depending on n number of quantas. Okay, 1 2 3 4, so n, h, nu. What is h over here? So basically this is n, h over here is Planck's constant, h over here is Planck's constant, h over here is Planck's constant, and this Planck's constant do carry the value, how much? 6.6 into 10 raised to power minus 34 joule second, right? You can take it to be 20 by 3 into 10 raised to the power minus 34. If I don't know about frequency, if in the question it is provided to you with the lambda term, so you can simply open up the frequency formula and write it for lambda. You can get the formula to be E is equals to NHC by lambda. NHC by lambda. So this is how you can solve. H is a constant, C is a constant, both are constant. C is what? Speed of light in vacuum, 3 into 10 raised to the power 8. So if you put directly HC can be calculated directly, you can write in place of HC 6, we can say 2 into 10 raised to the power minus 25. Okay, directly in place of HC you can simply write this as well, so as to easen up your questions. Many a times you will find there in question that different terms is given to you. Accordingly, you can substitute the values and find it all out. Right, everyone? Clear, everyone? Is that clear to you all? Yes, beta. Very good. Okay. If I do want to find it for 1 mole, so in place of n, I will write it for 1 mole. That is 6.022 into 10 raised to the 23. For 2, now there is a difference between the quanta and specifically targeting the light. For radiations, right? For radiations, we can say it as quanta. But if I am specifically mentioning that for light, the quanta are named as photons. Okay. So photon is for light energy. If I want to calculate the power, so power is the form having the formula energy by time. So accordingly, power is equals to whatever energy you are using the formula of, you can divide it by time, you will get it out in the power terms. Now, there is another thing, that speed of light is constant according to Maxwell. But no, it is constant only in vacuum. In different medium, it will change accordingly. In solid, it will change. In liquid, it will change. It will gas, it will change. It will change according to the medium that in which it is traveling with. Right? So this is about the concept that we did so far. Okay, one more thing about this concept only. If I use the formula, this energy formula, but there in the formula, multiple time there in the questions, you are provided energy in the electron volt units. You have to solve the energy in electron volt, and lambda given there to you is in angstrom for say. Directly you can use the formula 12400 upon lambda in angstrom. When you apply this formula, na, when you apply this formula, this one, yes, this one, when you apply this formula, you will get the energy in electron volt. Simply have to put the lambda value in angstrom given there to you, and you just have to use the formula. You will get the energy in electron volt. If let's say a nanometer given to you, in place of 12400, just use the formula. If in nanometer it is given to you, so just have to use the formula 1240 upon lambda in nanometer. Just use the formula, you will get the energy in electron volt. This is very simpler version because it will help you to solve the questions. Let me show you how. There are minimum number of questions. For say the calculation of energy of 1 mole photon. 1 mole NH nu. So 1 mole is 6.022 into 10 raised to the power 23. Energy you have to find out. H you already know, 20 by 3 into 10 raised to the power minus 34 joule second. Right? And frequency given there to you in the question is 5 into 10 raised to the power 14 hertz. So you just have to simply use the formula, put the values, and accordingly you will get the answer. Ma'am, I am class 8. I have the chapter, but it feels hard for me. Okay, you have this chapter, beta. This is for NEET we are discussing right now. All right, this is for NEET we are discussing. Okay, this is for NEET. This is for NEET. All right, fine, clear. Done. चले आगे. Okay, let's move. Again, this is the question. 100-watt bulb emits electromagnetic radiation of light of wavelength this much. Calculate the number of photons emitted per second by the bulb. Very good question. Beta, power given to you, that is 100 watt. 100 watt power given to you. Electromagnetic radiation of lambda wavelength given there to you. How much? 400 nanometer convert to meter minus 9 meter. Right? This is how you are converting it out. Calculate the number of photons emitted per second, time given to you by the bulb. So you can use the formula power is equals to how much? Power is equals to energy by time. In place of energy, you can use the formula. And time given there to you, how much? Second only. And 1 second only. So you can simply put the value of energy NHC by lambda. Because wavelength given there to you, right, everyone? Upon time period. upon time period, that is 1 second only. So you just have to put the formula of power 100 watt bulb given to you, and you have to calculate number of photon. In place of HC, simply write it as 2 into 10 raised to the minus 25. Lambda given to you, how much? Lambda given to you 400 into 10 raised to the power minus 9. And time given already there to you 1 second. Just have to solve and find the value of n. As simple. Okay. Yes, you can easily, if you are in class 8th, and accordingly this is parallel syllabus only, beta, no worries at all. You can easily attend the session, you can easily find the questions. It depends upon the level of question that we are discussing, that's it. The theory portion is the same. Okay. Yes, so this is how you are applying the concept. If you're getting the knowledge, you can easily good to go for these type of things. Okay, moving on to the very important concept, that is photoelectric effect. Now what is it, ma'am? Why we are using this photoelectric effect? Firstly, it was given by Edgeworth, and experimental proofs were performed by Einstein. Now, what is basically photoelectric effect? What is photoelectric effect? What is photoelectric effect? Let us discuss about the concept. See, over here, let us say we do have a metal. We do have a metal piece. We do have a metal piece. We all know that metal do contain the free electrons like this, right everyone? Yes, ma'am. Now the metal contains electrons over to it. We are passing on the radiations. Okay, energy E, that is equal to h nu, right? Planck's constant into frequency term. So we do have a metal. We are passing the radiations over to it. We're passing the radiations over to it. When we pass the radiation, the electron will do what? Electron will absorb that radiation. Now it's not like it will directly absorb and emit out. No, not at all. It will firstly take certain amount of energy to, overcome the force of attraction from metal. That is the work function. That is a phi. That is a work function. That is work function. That means certain amount of energy is required by this electron to get expelled out, to overcome the force of attraction from the metal surface. When that energy is compensated, it will then come out with the kinetic energy. Let us take an example of, for say your mother have given you certain rupees. How much rupees? Let us say your mother have given you 50 rupees. Your mother have given you, let us say 50 rupees. 50 rupees is the amount that is given by your mother. Now, certain cost is required to, let's say your mother have given you 50 rupees to purchase apples from the market, right? So, apple cost is, let's say 30 rupees. Let's say 30 rupees. 30 rupees the apple cost, right? Your mother have given you 50 rupees. 30 rupees is the apple cost. Now, what is the remaining amount? What will you do for the remaining amount? That will be in your pocket only, right? That is 20 number. Okay, so 20 rupees is your pocket money now then, right? So this is how this will also happen, that to this electron 50 rupees is given, but 30 rupees is utilized. How? To remove it out, right? Then the remaining amount, that is of 20, will be expelled out in the form of kinetic energy. Is the point clear to you all or not? This is how the process actually happens, right everyone? This is how the process actually happens, that the electron will be taking energy to do some work, that is work function. That is the amount of energy used by this electron to overcome the force of attraction from the metal, and ultimately the remaining energy is expelled out in the form of kinetic energy. So this is work function represented. This is just an energy term only, h nu naught. Then nu naught is what? This is threshold frequency. Now ma'am, what is threshold frequency? Threshold frequency, this is basically the frequency, minimum frequency to remove the electron. Minimum frequency to remove the electron. And what is work? What is this work function? The minimum energy required to remove electron. To remove an electron. So that is basically the work function. Now, here I am just wrapping it all up, that the total energy given there is equal to the work function, and remaining is the kinetic energy. If I want kinetic energy, it will be equal to how much? Half mv square. You all know that. It is equal to E minus phi. Yes, everyone. Clear, everyone? Right? Yes, beta. You want the break of 5 minutes? Sure. At 9, we will give a 5-minute break. Fine. No issues at all. Okay, then moving on to the kinetic energy formula only. E h nu and nu naught is h nu naught. Phi is what? What function? That is h nu naught. I'm taking h to be the common factor. Nu minus nu naught, that is the kinetic energy. Right? In place of nu, I'm just opening it up. C by lambda naught. Right? So taking the c to be the common factor. Hc 1 upon lambda minus 1 upon lambda naught. So there are different type of relations of kinetic energy, or we can say these work functions depending on the question that they are giving you all. Right? Yes. Charandeep is starting, Charandeep is present there in the session till like from the starting portion itself. That is why I can see that the guys are asking for the break. No issues at all. At fix sharp 9, I'll give you the break. No issues at all. Okay, so this is how I'm getting the kinetic energy term. Right, everyone? Clear? Everyone, is the portion clear to you all? This is how we can say the photoelectric effect do happens. Right? Right, everyone? Now, the question that they ask is like whether there is a time lag, or what are the important points about photoelectric effect. So let us discuss about it. See beta, if the work function, for say your mother have given you a very less amount. How much? The cost of apples that you were purchasing from the market is 30, and your mother is giving you, let's say, 20 rupees only. So will you go to the market to bring that apples or not? You will absolutely not go, right? Because you know that the amount, the cost of apple is much higher than the amount given by your mother. Similarly here as well, only when the incident energy radiations is higher than the work function, then only this ejection will happen. If it is less than the work function, then no ejection will happen at all. Right, everyone? This is the prior condition. Yes? Okay, fine. Fine. So this is the prior condition. Then only photoelectric effect will happen. So we'll cover certain points of photoelectric effect now. There is no time lag. Okay, threshold frequency we have already covered. Then moving on to number of photoelectrons. But a very important point, very important point. Have a look over it. Number of photoelectrons. How much photoelectrons will come out? Will depend on what? Will depend upon the energy? No. Will depend upon the intensity or brightness of light. Intensity of brightness, if you increase the intensity brightness, there is impact on the number of electrons that are coming out, that are photoelectrons. That means ultimately the current will change. So if you are increasing the intensity brightness, current will change. But if you are increasing the frequency, then current will not change. That means we can say over here that intensity will affect current, and frequency affect kinetic energy. So this is the relation. Intensity will not have any change on kinetic energy, frequency will not have any change on current. This is the relation. Okay? Yes, beta. It will do. Kinetic energy is increasing the frequency. Okay, so this is the concept. Kinetic energy does not depend upon the intensity of light. Stopping potential in another term. See, this basically this is the experimental setup, beta. This is the experimental setup. Have a look. This is a light passing over to the metal surface. Metal surface will expel the electron out. It will go to detector and to complete the circuit like this. So this is the proof that this metal is removing the electron, which complete the circuit, and we are getting it to be operated. So this is about the photoelectric effect. Due to the presence of light over the microwave surface, there is a ejection of electron. Now what is stopping potential? To reduce it. The opposite potential that we are applying to reduce it. That is equal to what? The kinetic energy divided by the charge. Kinetic energy divided by the charge. This is the stopping potential. Direct question can occur from this. Okay? Yes, beta. Yes. Okay, moving on to the graph that we are getting of this different portions. In your physics as well, I know this portion is there, right? Here as well, we are discussing it. As I told you, the frequency and kinetic energy have direct relation. So we are getting a direct linear graph, straight graph. This is the point from where minimum frequency, because as I told you, randomly it will not start ejecting electron out. It will take certain minimum amount. for it to eject the electron out, and that certain minimum frequency is what? It is threshold frequency. So we require this threshold frequency, then only the ejection of electron will happen, otherwise it will not. Moving on to the intensity of light. Have a look. If you are increasing the intensity, frequency is constant, it will not at all did any change on the kinetic energy. Kinetic energy will only be changed, if the frequency is changed. So this is the graph indicating you the relation between the two. Right everyone? Clear everyone? Yes everyone. Right? Clear. Then moving on to the next third graph. Frequency and number of electron, that is current. That is current graph. If you're relating the two graphs, you can see that it will not at all affect each other, but there is a minimum frequency at which the photoelectric effect will happen. You can see that this is the constant graph. Constant means if you are increasing the frequency, no change in current at all will happen. Right students? Here we are having this constant, but you can see that at low intensity, if the intensity of light is low, current is low. If the intensity is increased, then the current is increased. So we can clearly see that on changing the intensity, the current will also change. So I told you that intensity affect the current portion and frequency affect the kinetic energy portion. Right? Clear everyone? This is the discussion about it. Now let us cover your NEET question of the particular topic. So see over here, when electromagnetic radiations of wavelength this much falls on the surface of metal, right? Okay, fine. Electrons are emitted with the kinetic energy of this much. What is the minimum energy? That means energy is equals to phi plus kinetic energy. They are asking you about the minimum energy. That means they are asking about the work function. Energy of radiation of wavelength is 300 nanometer. Fine beta. 300 nanometer. So Hc upon lambda. You can use the formula is equals to phi. I need to find out. And kinetic energy is given there to you. Yes, ma'am, 1.68. Given it to be 1.68 into 10 raised to the power 5 joule per mole. Now, very important question, and majority student may do difficulty in this. May do mistake in this. May find difficulty in this. What are these? So here in this formula, if you do solve this formula, you will get the energy in terms of joule beta. But there in the questions, you can see that option given to you in joule per mole. Joule per mole, right? And this unit is also in joule per mole. For finding phi, you have to subtract this term from this term. But the unit of it is joule per mole and the unit of it is in joule. So you have to convert it in per mole as well. Right everyone? So how to do so? By multiplying it with Na, you will get it in joule per mole. Right? So you just have to put the values. What values? Accordingly put in terms of Hc 2 into 10 raised to the power minus 25. In terms of Na 6 into 10 raised to the power 23. In this lambda, you just have to put wavelength into 300 nanometer, that is 10 raised to the minus 9 meter. So simply you have to substitute the values. You have to substitute the value and you have to find this phi. See how easy the question became. If you do solve the complete values, you do write in terms of H, C, that complete values, you find the question to be very much difficult. But have a look, by just remembering few things, few we can say values, that question will be very much easy for you all. Right everyone? This is how you have to solve the questions. This is how you have to solve different numerical concepts, the calculative portions. All right, and you will ultimately get the answer to be how much? I don't know the final answer. Okay, you can solve it out and do tell me in the comment section what is the final answer that you all guys are getting. Okay, fine. So yes, okay. Same type of questions, multiple time you will get the same type of electromagnetic radiation of wavelength this much, subjected to metal surface having work function this much. What will be the maximum kinetic energy? Again the same concept. Now they are asking you about kinetic energy. E. They are not giving you E. They are giving you lambda. That means which formula? NH Hc by lambda. Work function they are giving you how much? 12.8 electron volt. And kinetic energy they are asking you. Now in this formula, remember I told you whenever they are giving you lambda in angstrom, just simply you have to write the formula of E, that to be 12400, right? And lambda in angstrom is 314. See how simple it is. You just have to simply solve it out, and 1 2 point, like this will come out to be in electron volt, 12.8 electron volt, and kinetic energy. Accordingly you can solve it all out. Accordingly you can solve it all out, and you will get the answer to be this much, right? This is how you have to solve these type of questions. These are very simple. All you need to do is hard work, not smart work with hard work. Okay, many of the students continuously do that hard work to solve the questions by the calculation, that difficult calculations, but actually it is not. It is very simple, students. All you need to do is just use these smart tricks that I am telling to you throughout my sessions. Okay, okay, fine. And moving on to this question, have a look. What happened to the kinetic energy of the ejected electron if frequency of incident light is doubled, right? If frequency is doubled, then what will be the impact on the kinetic energy, students? What will be the impact on kinetic energy then? Tell me. Yes, tell me. What happened to kinetic energy if the frequency is doubled? Have a look. See, let us say the metal is there. If the energy of incident radiation and the emitted energy, kinetic energy. I'm just taking an example. Let us say it to be as for say 50. Amount of work function is 30 and removed is 20. I have taken the example. Right? Now, over here, if I am changing the condition, they are saying that what happened to kinetic energy if the frequency of incident light is doubled. See beta, if energy is directly to frequency, if the frequency is doubled, I am considering energy also to be doubled, right? So if I am taking another case where the energy is doubled, that means 100. Work function is same only. Now the kinetic energy will be how much? It will be the remaining energy, 100 minus 30. 100 minus 30 comes out to be 70. Right, everyone? Yes, ma'am. Correct, na, beta? This is how I'm getting the kinetic energy. Compare it with the previous one. Initially, I was having 20 kinetic energy for say. Now I am having 70. By doubling the frequency term, whether the kinetic energy is doubling? No, ma'am. It is more than double. It is more than double. It is more than double. This is the concept. Right? This is the concept. Now you can directly apply it to the formula as well, and then link them as well. You can do that portion as well, but you can simply see it over here, right? Yes, very good. Mortal Emperor, very good beta. Your name is, I know, some different name, but you have written something else. But yes, you are right only. Kinetic energy become more than double. Yes, students. This is how you have to solve this portion. Okay, fine beta. This is all about photoelectric effect. Now we get to know about the dual nature of dual nature of radiations. We can say that the radiations do carry the wave nature as well as particle nature. We have proved about the black body radiation, about the photoelectric effect. They both, consider the light as particle. Now another concept is the spectrum. Right, beta, right. Now another concept is spectrum. Now what is spectrum? Spectrum is just simply, we can say, the branch of science. What we are dealing with, the spectra concept is spectroscopy. Now what basically is spectrum? It is just the photograph of an element. This is the photograph of an element. When we are under radiation is passed through a spectroscope, right? The prism, we are getting a photograph, and that is the spectrum, right? So we do have, based on the nature, based on the region, different type of spectrum. Based on nature, continuous. Discrete means discontinuous. What is continuous spectrum? Where there is no as such partitioning line, one color merge with the other color. And in discontinuous, there is the bands, the line spectrum and the band spectrum. There is partitioning line. Let me show you how. See beta, this is continuous. This is continuous spectrum. There is no partition at all. There is no lines at all. But these are discontinuous. You can see over here, there is lines, right? So these are discontinuous spectrum, where the one color do not completely overlap with the other color. This is discrete. Line spectrum contains lines in it, and band spectrum contain broad portion, right? Broad portion, just like the previous one I have shown you. And the broad portion, the bands in between the continuous, we can say that is the discontinuous band spectrum. Based on origin, how the spectrum arises, whether it is absorption, whether it is emission. Let me show you how. have a look beta in this structure over here. Just have a look. This is hydrogen gas that is present inside the discharge tube. Force. This is hydrogen gas that is present inside the discharge tube. You are just passing the radiations of it through the slit to the prism, and the prism will do what? Prism will split them and will create them on the spectrum form. Right? This is the spectrum I'm getting. So this is hydrogen gas that is emitting the radiation. That is emission spectrum. This is how I'm getting the emission spectrum based on the origin. It is emitting itself, right? The second, so this one is emission spectrum. Emission spectrum. Now the another one is absorption. Absorption. In this absorption spectrum, I do have this sample for say any XYZ sample. In this particular case, I'm taking NaCl sample, right? I'm passing the normal light, that natural sunlight that contain all the broad electromagnetic spectrum. So here I'm passing the radiation over to it, right? And certain colors of the complete light are absorbed from it. Right now, I am completely seeing that some colors are basically absorbed from it. Remaining is transmitted. So this is transmitted light to the prism. Prism will separate them all out, right? And I will get this type of spectrum. You can clearly see over here that over this spectrum there is some vibgyor and certain colors are missing from in between, like they are something we can say. Yes, I'm giving you the break right after this only. Okay. Yes. Okay. Yes. I just forgot to grip the break. Yes, I remember. I'll give you the break just after this concept only. Okay. So this is about the absorption spectrum. There are some colors are missing from between, but here we can say some colors are just, emitted out only. So these are two different type of spectrums. Absorption will absorb some, emission will emit some only. So I hope that this portion is clear to you all guys. Yes or no? I'm giving you the break only. After this, I'm giving you the break only. Okay, so this is about the spectrum. So we will discuss about the next next thing in next coming up portion. Take some 5-minute break. Okay, I'm giving you the 5-minute break. 5-minute break. I'm giving you some 5-minute break. Hold on for a while. Giving you the 5-minute break. Just wait for 5 minutes and have some water or okay. I'm coming back in 5 minutes. All right. Bye. Ciao. I guess now my voice is coming to you all, guys. Yes or no? Okay, okay, okay. Now am I audible? Hello, everyone. Now am I audible? Am I audible now? Am I audible now? Am I audible now? Am I audible now? Okay, you all can hear me? Okay, okay, okay. I guess now you can hear me all out, right? Okay. So we have discussed so far many much things. We have discovered about, we have covered the discoveries of subatomic particles. We have covered about the models, right? The models. Yes. Okay. Fine, 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 beta. Fine. We have covered the models. We have covered about the wave nature, right, of radiations, about the particle nature, about the black body, about the photoelectric effect, about the spectrum as well. Now we're gonna start the third model, that is Bohr model, right? Before Bohr, I already told you about the achievements, the developments. First development was about what? First development was about the, we can say, dual nature of electromagnetic radiation, and the second was the spectrum, right? Okay, so what are the postulate of Bohr model? Simple model. It do discuss about single electron species only, like hydrogen, like helium positive, like lithium 2 positive, like beryllium 3 positive. So it is valid only for single electronic species. That was a limitation as well of his model, right? Moving on to the postulates of it. So firstly, the atom contains the infinite circular orbits. They are infinite, n number, right? They all are known as stationary orbits because they do contain the fixed energy. Stationary orbits because of their fixed energy. That means if the electron is present in a particular orbit, it will not at all change its energy. Then in the Rutherford model, we have discussed that if electron is moving, it will do what? It will release the energy, right? But here we are discussing that if electron is moving, it will not at all change its energy because they are stationary orbits. They have fixed energy only, and the distance of the electron from the nucleus is also fixed. It will not at all changes, just like the Rutherford, just not unlike the Rutherford model that stated the energy will decrease. The energy will decrease, it will undergo the spiral motion, but here it is not at all happen, right? And now the question is quantization of angular momentum. What is the meaning of this thing? That electron will revolve only in those particular orbit where the angular momentum MVR is an integral multiple of h by 2 pi. This is the integer value, h by 2 pi, that is the integer value. So here n can be 1, 2, 3 and so on. So electron will revolve only in those particular orbits whose angular momentum is an integral multiple of this thing. This was also your one of the PYQ covered, right? That electron can revolve in which angular momentum justify, because if you put the value of n to be 1, it will be h by 2 pi. If you put 2, so h by pi. Accordingly, you will get the answers, right? So this is how we are getting the justification. Moving on to the next, if the electron is not moving from one orbit to another, it will not lose energy, it will not gain energy. But yes, if it change its orbit or path, energy low to energy high, if it absorb the energy, it will excite itself, it will jump from low to high, right? But if it move from high to low level, it will release energy, depending on the transition. Accordingly, it will change its energy. Okay, so this is the concept, this is the postulates. Okay, so depending on what is happening over there, it will do the transition. Moving on to next point now, students, that is, unless and until electron is there in a specific orbit, it will not lose at all. But here we already have covered that nucleus and electron must have that force of attraction there between them, right everyone? But there is other force as well operating, right? That is repelling it, right? There are two type of forces, centripetal forces and centrifugal forces. Centripetal will attract, centrifugal will, move it out from it. Together they both balance each other. That is why electron is continuously moving in that particular orbit only. It will not get attracted, it will not get repelled, right? This is the point. Now moving to success, that Bohr atomic model was able to explain the stability, right? Rutherford was not. And moving on to Bohr concept was able to explain the hydrogen spectrum as well, right? Okay, yes. So this is about the Bohr model achievements. Now the applications of it. I will cover all the applications. Firstly, the radius of various orbits or shell. So the radius is equal to just writing out the constant value r naught n square by z. Okay, how I'm getting the value? See, the radius of nth orbit is equals to n square h square upon 4 pi square mkz square. In the class, we must have covered these portions. We already have covered the portions that how we are getting the radius relation, the volume, the radius relation, the velocity relation, the energy relation, the kinetic energy, the potential energy, and different type of energy. We already have covered that in the class, that how do we getting the energy, the radius, the velocity, different formulas. But here in this particular portion, I'm just directly writing the formulas. Okay, right? So r naught over here is how much? So radius equals to 0.529 n square by z in angstrom. We are using this formula depending on the n value. N is what? The shell number, and z is what? Z is the atomic number, right? Depending on whose atom we are discussing about, lithium, sodium, whatever the element is there. All right, moving on to iska. Okay. Okay. Give me a second, beta. Give me a second. Just give me a second. All right. Fine. Okay, fine. So this is about the radius relation. Moving on to the second relation, that is of velocity. That what is the velocity of electron if it is particularly moving in a particular orbit. So velocity is related by the formula v of nth orbit is equals to v naught. Again, z by n over here. Now what is v naught over here? What is v naught over here? 2.18 into 10 raised to the power 8 z by n centimeter per second. So this is the velocity relation. Now just have to substitute the value of z and n. That's it. You are ready to go with the question, right? Similarly, we can go with the energy formula. Energy is what? Minus 13.6. Minus 13.6 z square by n square. Electron volt per atom. You can take it in joules per atom as well. You can know the relation between the conversion of electron volt to joule terms, right? Minus 2.18 into 10 raised to the power 18 z square by n square in joule per atom. So depending on in the units that you are taking, you can accordingly substitute the value. Okay, right? So this is how the energy relation actually proceeds. They might ask you the time period as well. So time period is taken to be as time equals to distance upon, we can say, speed equals to distance upon time. So time is equals to distance upon speed, right? Distance upon speed. So distance is 2 pi r and speed is v, right? So you can take it as time period is directly proportional to r by v. You can substitute the value of radius and velocity. Radius is how much? It is proportional to, you can take it in terms of proportionality sign. Proportional to radius is how much? Proportional to n square by z. And velocity is proportional to z by n. So accordingly, you can take the time period formula to be proportional to n cube by z square. And time period is what? Time period is inverse of frequency. Remember, time period is reverse of frequency. So accordingly, I can use this formula of time period or frequency depending on whatever thing given there to you. Okay. Ma'am, your voice is not audible properly. Beta, is it so? Whether my voice is not audible to you clearly, is there any problem in that? Do tell me. Do tell me, beta. Is there any problem in my voice? Whether my voice is not that much clear to you all guys? All right. So this is how I'm relating the formula. Then moving on to certain type of energies, the kinetic energy, total energy. So just writing the kinetic energy formula. Okay. You can use directly formula in different type of questions. So K Z E square upon 2R. Right. So this is the formula of kinetic energy. Moving on to the total energy. See, total energy is just the same. Just change the sign. K Z is square upon me 2R. And moving on to after that is potential energy. Potential energy is same formula just like kinetic energy and potential energy. Just have to take Z is square upon R. Only difference is among these terms, right? Now I am taking the ratio of them. I'm taking the ratio of kinetic energy. I'm taking the ratio of potential energy with this total energy and potential energy. Okay, total energy and potential energy. I'm taking the ratio of them. So I do know that over here the formula is just like the same only. If I do write it 1 by 2, 1 by 2 in negative term, and this is minus 1, right everyone? K z is square upon r, k z is square upon r, k z is square upon, I'm cancelling the term of the 3, right? And on solving it all out, I can multiply it by 2 and we'll get the formula of 1 ratio minus 1 ratio minus 2, right everyone? So this is how I'm relating the 3. I'm taking the ratio of all 3. They can directly give you the potential energy and ask you the kinetic energy. So you can directly substitute that kinetic energy and total energy, and ma'am, one and only same thing, just having different signs. But kinetic energy is what? If I do take the half of potential energy, I will get the kinetic energy with a negative sign, right? Right? This is how. If I do want to relate potential energy and total energy, so total energy is equal to potential energy, just we have to divide the potential energy, keeping the sign to be same only. This is how I can get the formulas. This is how I can get the formulas. This is how I can get the formulas, the relation between the 3, right? Okay, yes, clear everyone? Ma'am, I don't understand structure of atom. It is so hard to learn. Beta, see, listen very carefully. That structure of atom is very simple chapter. Let me clear you. This chapter is very simple, right? All you need to do is just max question practice after the concept revision. That's it. When you are revising the question, when you are revising the concept, after that you are doing the questions, then only you will get the concept to be very much clear. Otherwise, it will be difficult for you, right? Okay, otherwise it will be difficult for you. Okay, so this is how you have to just frame the questions accordingly. See, they are asking if the radius of fifth orbit of lithium ion is x, calculate the radius of third orbit of helium. You all know the relation, beta. Radius relation is r naught n square by z. If they are giving you the radius of lithium 2 positive, radius of fifth Bohr orbit of lithium, so I'm writing lithium 2 positive, r naught in place of n square, it is fifth orbit, so 5 square. For lithium, atomic number is how much, beta? 3, right? Right, clear everyone? I am taking the ratio of it to be calculate the radius of third orbit for helium. Third orbit of helium. Third orbit of helium is like 3 square. For helium, the value of Z is 2. Right, everyone? Just have to simply write the values. How? R naught is cancelled. Right, everyone? Okay. Radius of lithium given to you is X. You just have to find this. You just have to find this. You just have to find this. You can accordingly substitute the value and you can definitely get the answer to be X upon radius of helium positives come out to be 5 square means 25. You can simply write it as 25, 5 square divided by 3. Divided by 3. And over here 3 square. 3 square divided by 2. So you just have to solve it all out and accordingly you get the radius of helium in terms of x. Right? Fine? Okay. So one student is asking a doubt that, ma'am, I have a cumulative exam day after one, have 3 chapters in chemistry, basic concepts of chemistry, structure of atom and classification. How to learn them all in one day? Better just revise the concepts, by just going through the notes that you have created during the class. Just keep on revising that concept and ultimately it will be very easy for you to overall sum them all up, mug them all up and ultimately attempt your test paper. It is not hard, that much hard. Just be consistent and you are ready to go for the concept. Okay, fine, beta. These are all the concepts that we have discussed about the time, radius and energy terms. Now let us discuss upon some more terminologies. Ground state. What is the meaning of ground state? For single electronic species, the lower energy state. We are discussing about the Bohr model only. We are taking the single electronic species only. That means only single electron is present, right? So the ground state for single electron is first energy only. Moving on to excited state. Excited state is the upper state, n plus 1. Okay, first excited state. That means n value comes out to be 2. Second excited state, n value come out to be 3. Third excited state, n value come out to be 4. X excited state, n value come out to be x plus 1. So whatever the excited state given there to you, just have to add 1 to get the actual n value. Now is ionization energy. What is the meaning of ionization energy? That means the transition happen from any n value for say for any n value. Finally, when it undergo the transition, n2 will come out to be infinity beta. Right? Ionization, what is the meaning of ionization? Ionization means to remove the electron out from an atom, right? So we are removing it out. We are sending it to some infinite energy state. So that is ionization. How do you are getting ionization? To move it to infinite level, right? Separation energy is, what is separation energy? N1 can be whatever the thing is, 1, 2, 3, depending on the different conditions. Separation is also to move it to infinite value. But here the N1 can never ever be ground, right? It can never be ground level. It is always the excited level. Electron will jump out from the excited level. That is separation energy. Okay, this is how the concept actually operates. Now if we do discuss about the excitation energy. Excitation energy, yeah, or we can say the change in energy. Excitation energy, the change in energy. So how to calculate it out? Excitation energy is basically the difference between the two, delta E. That means E2 minus E1. E2 minus E1. We can simply solve it by putting the formula, and we are getting the final relation to be like this, where N1 represent the lower energy and N2 represent the high energy, upper energy level, right? So we are getting the difference in electron volt per atom. That formula only we are putting usually using over here. Or if you want to use that kilojoule or joule wala formula, you can simply write the value 2.1 and 10 raised to our 18. 1 by n1 square minus 1 by n2 square, right? Accordingly, you'll get the difference of the energy, right? If I ask you about the ionization energy term, ionization energy, ionization energy, ionization energy. So basically here we do have the second level, N2 to be infinite, N2 to be infinite. So accordingly the E2 will come out to be how much? If I am dividing something by infinite value, formula I do know about 13.6 z square by n square, and if this is infinite, so overall this value will come out to be 0, right? So ionization energy will come how much? E2 minus E1, E2 minus E1, and I know that E2 is 0 because accordingly the n value is infinite. So ionization energy is just the opposite of energy of the first, whatever the level, initial level they are giving you, right? So whenever they are asking about the ionization energy, just change the sign. That's it. You're getting the final answer, right? So ionization energy of hydrogen, for say they are asking you about, right? Hydrogen contains single electron in the ground state only. That means the transition occur from ground state N1 to N2. That means ground state, that is ground state, first to infinite level. For hydrogen, ionization energy will come out to be minus energy of first state, that is minus of minus 13.6 z square for hydrogen will come out to be 1 square by n square, that is 1 square only, right? So we will get the answer to be 13.6 only electron volt per atom. So this is the ionization energy for electron of hydrogen. This is how we are getting the formula, right? Clear? Clear. This is how you are getting the formula. Now let us discuss about all this concept specifically representing our hydrogen species. We are discussing in our syllabus hydrogen atom is there. We are discussing about the spectrum of hydrogen, right? So this is hydrogen. This is hydrogen. This is the spectrum of hydrogen. Now, that emission spectrum I told you about hydrogen to taken in that cathode ray tube, right? So now over here I'm doing what? Over here I'm taking the spectrum of hydrogen. I'm getting these type of transitions. What are these? These are different energy levels. How, ma'am? Beta, you can simply apply the formula that energy of nth is equals to minus 13.6 z square by n square, right? You can simply put it for hydrogen. So hydrogen, z value is 1 and n value accordingly you can substitute over here 13.6, here minus 13.6 minus 3.4, right? Similarly you can substitute the value. Similarly, you can substitute the value for second, for third, then fourth and fifth and so on, right? Just solve it by your own. I'm not telling you right now, just have to solve it by own by putting the values either in kilojoule per mole or either in electron volt per atom. Whatever concept, whatever formula you want to use, you can accordingly use the formula for energy. Right now, I have given you this in electron volt per atom. Electron volt per atom. Electron volt per atom. Right now, I have taken it for electron volt per atom. Okay? Yes. Clear? Yes. Fine. Clear? Yes. Okay, then moving on to these are the different type of levels that I am getting over here. You can simply see that on moving from lower to higher level, the energy gap decreases, right beta? This is the energy gap. You can simply see over here, this is the energy gap that is continuously decreasing. That means I can summarize it as E2 minus E1 is greater than E3 minus E2 is greater than E4 minus E3 is greater than E5 minus E4 is greater than E6 minus E5 and so on. This is also another very important concept, right everyone? Right, clear? So one series I'm getting when the transition happen from higher level to first ground level, right? So I am getting over here Lyman series. The region, the energy that is released comes under which region? That is UV region. So Lyman is the one that is coming under UV region. Then the second type of transition is when the electron jumps from higher level, any higher level, to the second level, that is Balmer series. That is only visible series. Otherwise, any other series is not visible to us. Moving on to next transition, when the electron jumps from higher level to third level, right? That is Paschen series coming on infrared region, IR region. Moving on to Bragg series and Pfund series, and similarly Humphrey series, right? Yes, clear everyone? Clear everyone? Clear everyone? Okay, so this is how the spectrum of hydrogen looks like, and these are the transitions that undergo making the transition with the spectrum to be like this. So Lyman is very high energy, right, series. So that is why it is coming under the high energy range. Then Balmer, then Paschen, Bragg, Pfund, right? So these are the transitions that are happening over here to be like this. These are the different transitions that you all are watching over here. Okay, so this is how the actual series happen, actual transition happen, right everyone? Then moving on to some specific terms that we usually use there in the question. What is first line? What is minimum energy? What is maximum energy? What is minimum energy for Lyman series? These are the different terms that we usually use. So what is first line? First line, also termed as alpha line. Also they can ask about the minimum energy or minimum frequency, and we know that energy frequency are directly related with each other, but lambda is inversely, right? So they can ask you about maximum wavelength as well. When the transition N2 is what? N1 plus 1. Okay, that is minimum energy. That is minimum energy. For example, if hydrogen is having the electron over here, these are the different energy levels, right? So just upper transition from 1 to 2. This is the alpha line. This is the alpha line. This is the alpha line, right? Minimum energy, minimum frequency, maximum wavelength. Moving on to the last limiting line. Last is what? When the electron transition is from the energy level, whatever the energy level we are discussing, to the infinity level, right? So here the transition actually happens. N2 comes out to be infinite in this case, right? So the transition is from N1 to N2, and the N2 is infinity. This is the last limiting line, right everyone? Moving on to second line. But what is second or beta line? Where the electron transition happen from third level to upper level. That means if the electron over here is present and it is moving, jumping to the 2 more upper level and 3 over here, so that is why I'm getting the beta line, right? This is how I'm getting the beta line. Moving on to the next transition, that is gamma line. Now what is gamma? Gamma is when the electron transition happen from a certain level to 3 higher level, N1 plus 3. So these are the different lines that I am getting over here. So whenever they ask you about the calculate the gamma line of Bragg series. Bragg series. Suppose they are asking about this thing, Bragg series. Now remember that Lyman is the first, Balmer is the second. That means N1 over here is 2. For Balmer, N1 is 2. Now they are asking about gamma line. Gamma means you have to add 3 to the N1. That means you are asking about the transition from 2 to 5. This is how you have to solve it all up, right? Yes, this is how you all have to solve it up, right? Sometime there in the question they ask you in terms of wave number or wavelength. All right, so there in these type of questions, how to solve that wave number or wavelength term of RH. So let us calculate the lambda. Beta, I already told you about delta E formula, right? The delta E formula. Delta E is equals to, we can say that E naught 1 upon N1 square minus 1 upon N2 square. Depending on the unit that we are using, we are just writing E naught over here. Now, if I do write hc by lambda in place of this, right? hc by lambda, and that hc is moving over here. I do write hc by lambda. And that hc term is going over here. I'm getting 1 by lambda is equals to E naught by hc. 1 upon n1 square minus 1 upon n2 square. Just solving the value, I'm getting the 1 by lambda, that is the wave number in terms of RH. 1 upon n1 square minus 1 upon n2 square. If I'm taking it in centimeter inverse unit, right? Centimeter inverse 109,678 centimeter inverse. This is the value of RH usually we do use. But multiple times there in the question they ask you directly in terms of RH. Just solve the formula directly in terms of RH. Find the value in terms of RH. So you just have to put the value. You just have to put the value. Ma'am, tell about Indian Railway. But am I taking to you Indian Railway classes over here? Right? Am I taking Indian Railway classes over here? So why are you asking about Indian Railway? Come on. Indian Railway. Come on. Okay. For Indian Railway, you have to go to some other channel. This is for NEET warriors. This is for NEET warriors. Okay. Moving on to the energy of electron in the ground state of helium is this much. Then that of electron in second state of beryllium. See how the equation asked, right? So energy. Energy, you can simply write E naught minus n square by, z square by n square. Z square by n square. This is the formula that we do usually use. Irrespective of the unit, E naught is a constant, right? Okay. So energy of electron in the ground state of helium positive. For helium positive minus E naught. Ground state for helium positive. See beta. Helium, atomic number 2. Ground state is first. So 1 square and 2 square, right? I am taking the division with this. What else? Beryllium 3 positive. So I am having energy for beryllium 3 positive E naught n z square for beryllium. For beryllium, what is the value of atomic number? Yes. Obviously, it is 4 square, right? So, atomic number is 4 square divided by n. The n value come out to be for beryllium is 2. They are giving us over here. So, just write over here 2 square. And here, they are giving you the energy of helium comes out to be minus x. Here, they will cancel out with each other, right? And this also will be cancelled out there with each other. Are you getting my point or not? Are you getting it or not? Are you getting it or not? Right? Yes, beta. So just have to simply find out for beryllium 3 positive, what is the value that you are getting. See, this is 4 and this is 4 square, right? This is 4, this is 4. All the things will be cancelled there with each other and you will simply get them to be equal. Like energy of beryllium 2 positive, beryllium 3 positive will come out to be equal to energy of helium positive, that is minus x. So this will be the answer that you guys gonna get. Okay, how simple is it? Right? Yes, very nice. Who told me this answer? Oh, genius edits. Very nice, beta. Very nice. These are the questions that are very much useful for you all guys, and all other questions that are, made by the concept that we did so far. This is how you have to apply the concept, right? It is not any other concept. It's the same concept that I told you that in theory portion. It's only about the question practice that you do. It's only about the questions. You do max to max question, ultimately you'll get a very decent score, right? Yes. Okay. Fine. Yes, this is the question and this is the answer you're getting. The radius of second Bohr orbit of helium is this much. What is the radius of third Bohr orbit? Same question. See, same type of question. They are relating the radius. To tell me, beta, this is the second orbit of helium positive. So radius R naught n square. N square is what? If I'm talking about the helium positive, n square for the second orbit by z. N square by z. For helium, the z value is 2. Taking the ratio with radius of third Bohr orbit of lithium 2 positive. Third Bohr orbit 3 square and lithium is 3. So bus just write the value to be over here. The radius given to you is 105.8. Accordingly, you can get it for lithium 2 positive to be how much? You can get it for lithium 2 positive. Just take it to be like this. Okay, I'll solve the complete question. Otherwise, I think that you guys gonna find any difficulty. 105.8 by radius of lithium 2 positive equal to, you can simply write as 2 by 3 over here. You will get the radius of lithium 2 positive to be how much? But you will get 105.8 into 3 by 2. This is how you have to solve the question and accordingly get the answer. That's it. As simple. Okay. Fine. Clear? Shall we move? This is the type of question that they majorly ask in the question. Okay. So these are the different type of questions that I told you. The limiting line of Lyman series. So here you have to limiting line. Limiting line is minimum frequency, right? 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 Yes, as I told you. Okay. Limiting line of Balmer series. So Lyman is n1 is equals to 1 and you are putting it for 2. So then here n1 is equals to Balmer. Second, putting for just upper level, right? Third line of Balmer series, third line is what? N1 is equals to 2 for Balmer, and third is you are just adding 3 more to it, means 5. First line of Paschen, Paschen is Lyman, Balmer, Paschen, third number. First line, just upper one, that is 4. So these are the transitions. These are the N2 values, okay? These are the N2 values. Just the previous thing I told you about the different range, about the different values, okay? Okay. Last limiting line you mentioned, beta. Last limiting line is for infinity. What? Infinity. So you are checking for infinity. Okay, infinity value. Similarly, there are n number of questions, beta. There are n number of questions. We're gonna practice all these questions. We're gonna practice all these questions in a separate session where I will be covering all the important questions of this chapter. Right now, I'm telling you the major two questions that are asked there in your NEET examination, parallel along with the topics that we did so far, right? Okay, moving on to the spectral lines. Very important questions. Very important. Okay, spectral lines. What is the meaning of spectral line? I'm taking just an example of transition from n is equals to, we can say 4. Okay, 4 to first, 4 to first, 4 to first. That means ground state. I'm taking this transition, beta. Very important. Just listen to me very carefully. Okay? Okay. So transition is from fourth to first. So this is an atom forcing. This is an atom. First level, second level, third level, and this one is your fourth level, right? Yes, ma'am. So these are the different energy levels that I'm showing over here. This is your first level. This is your second level. This one is your third level, and this one is your fourth level, right, ma'am? Clear, ma'am. Now the transition actually happened. How the transition basically happened? The transition electron is present in the fourth level. You can say third excited state as well. Third excited state as well, right? And it is coming to the ground state. So what are the different possibilities that you can get? What are the lines that you will get? So you can draw it directly to be like 4 to 3. There's a possibility of 4 to 3. 4 to 3. Or, ma'am, it also can happen like 4 to directly 2 as well. 4 to directly 2 as well. 4 to directly 2 as well. Or, ma'am, it can happen from 3 to 2. Or 3 to 2. 4 to 2. Or 3 to 2 as well. Isn't it? 3 to 2 as well. Like this. Right? Or, ma'am, it can happen like 4 to 1. Directly from 4 to 1. Okay, 4 to 1, 4 to 1, like this. 4 to 3, 4 to 2, 4 to 1, like this. 4 to 1, like this, right? Or it can happen from 3 to 1 as well, ma'am. Like 3 to 1 as well, right? Or it can happen from 2 to 1 as well. It can happen from 2 to 1 as well, like this. So there are different lines that I am getting over here. Right? Total, if I count any other possibility possible, do let me, beta. Right? There are only these 6 possibilities. Right? So we can say that total number of spectral lines that I am getting over here is total spectral lines that I am getting over here is number 6. Right? Number of lines are 6 over here, under which these are the lines of particular series. When the transition happened to first level, we know them as Lyman series. Lyman series. When the transition happened to second level, Lyman, then Balmer series coming under visible region. Then this is your Paschen. So we can say under Lyman, there are 3 Under Lyman, there are 3 lines. Under Barman, there are 2 lines. Under Paschen, there are single line. There is single line, right? So these are the spectral lines that I am getting over here. Now the question rises that, ma'am, whether we have to do all these things and no other simple formula we can use. Yes, beta, you can use. You can use. What formula you can use over here? Have a look. You can use the first formula, total number of spectral lines. Total spectral lines. How? You can find it out to be delta n into delta n plus 1 upon 2. This is the first formula. What is delta n over here? But delta n is the change in the transition. That means 4 minus 2. For example, that one I'm taking 4 to 1. Right? So delta n comes out to be 4 minus 1 comes out to be 3. Right? Just push the formula spectral lines. SL is the spectral line. 3 into 3 plus 1. That is 4 by 2. Right? So 3. So you are getting it to be 6 only. And that is what I told you. Total spectral lines are coming to be 6 only. Right? So this is the first method of calculating the total spectral line. The second method, if the transition occur to ground state, that means you are now confirming the N2 to be 1 only, the ground state, N2 to be 1 only. So here you can simply use the formula spectral lines equal to N into N minus 1 upon 2. That means in the delta N you have already taken that N2 minus N1 to be 1. Right? N2 is 1 over here, right? That means the lower value comes out to be 1 over here, right? Clear? Is that clear to you all? So here we are taking the spectral lines formula like this. For example, in this single formula only that I have taken 4 to 1 transition. So N is the 4 value. So spectral lines will come out to be 4 into 4 minus 1, that is 3 upon 2. It will come out to be 6 only. This is ground state only, na? Firstly, the ground state only. So we are getting the 6th answer only in this formula as well, right? So another third formula that we do use for spectral line calculation is the spectral lines in series. That means in a particular series, in a particular region, if I want to calculate the series line, that means how many spectral lines, if the electron undergoing transition from 4th to 1st state, how many lines are there in the Lyman series? Let's say they are asking about this. So you just have to subtract the N2 minus N1. N2 minus, and you just have to use this formula. For example, I'm taking it for 4 to 1 transition, the Lyman series. So I'm using the formula N2 to be 4 and N1 for Lyman series is beta 1 because Lyman is for 1, right? So we are using the formula to be, okay, so okay, so it is over here coming out to be 3. I just got wanted. Okay, so this is how we are getting the formula. Okay, so this is how I'm getting the formula. Then moving to the second, that is Balmer. Here we are undergoing the transition from 4 to which level? 4 to which level? Beta Balmer is for 2. So 4 to 2. I'm getting how much? Only 2 lines. Have a look. Lyman we are having 3 series. Balmer we have only 2 spectral lines. Right? In the next, that is Paschen. In the Paschen series, I'm getting 4 minus 1 because 3. 4 minus 3. Paschen is for Lyman, Barman, Paschen. So I'm getting it out to be 3. But this is how I am getting the different regions, like different spectral lines of the particular series. Okay, so this is how if I do total add them all, I am getting the value to be how much? I am getting the value to be total 3 plus 2 plus, oh sorry beta, this is 1 only, no? So I'm getting the total number to be 6. This is how I have to solve the question, and this is how I'm getting the final answer. I hope the portion is much more clear to you now. This is how I'm getting the spectral lines to be like this. So this is how we do have covered the portion. Now we'll cover the drawback and we'll wrap up the topic till this portion only. The quantum portion will be covered in the next class. Okay, we will cover this till drawback of Bohr model. So first drawback was it was just applicable for single electron only. For multi-electronic species it was not at all applicable. Now the second question is that it do state about the quantization of angular momentum. Now what is the reason why the angular momentum is quantized? It was not at all justified. Splitting of spectral lines, like what is the reason behind the spectral lines to get split up? right? In the presence of electric field, it is known as Stark effect. In the presence of magnetic field, it is known as Zeeman effect. Now, what is the reason behind the spectral line splitting? It was not at all explained by the, we can say, Bohr model. Then, fine spectrum. Finest spectrum of spectral lines, it was not at all justified. So, these are the ultra fine spectrum. When we do visualize the spectrum, we will get the minute lines as well. Now, what is this? Why are these? That was not at all justified. So these all are the different type of drawbacks, different drawbacks of the Bohr model of an atom, right. So this is all about the drawback of the Bohr model. We will cover the portion till here only, and we'll discuss the rest of the portion in the upcoming classes. And I hope the portion is clear to you all, guys. So far, do let me know in the comment section that how was the session for you all. Tell me about the feedback of it. After the session end, I want my students to tell me how was the session for you all. Like Charandeep, how do you feel about the session? Because I can see that student from the starting itself, right? Moon, okay, hello, unknown, Jishan, Lucky, and all other students, Vishan, all of the students, whosoever is attending our class, do tell me how was the session. And if you are attending the session, if you forget to like the session, that is very bad. Just like the session, hit that like button, because your like mark the attendance of the active students, the actual NEET warriors who are dedicatedly watching our session, who are very dedicated for the future preparation, right? Future exam, that is your NEET examination, right? So that is all from my end. I hope the session was clear to you all, guys. Do tell me about next class. Just stay connected with us there in the channel. Just click that notify me button of upcoming class. That is what, whenever it is scheduled there in the session on the channel, you just have to stay connected with us, subscribe to this channel. Next class will be of periodic properties beta. We will cover the periodic properties chapter. And thank you so much, and just tell me about the feedback of the session after the live end. Okay, do tell me there in the comment section after the live session ends. Okay, all right. I want each and every one of you to answer me the question that I have given you in the homework. And that is all from mine. Bye bye, take care. Whosoever chapter you want me to cover in the next class, just also mention that as well in the comment section, because your live comment will automatically disappear beta. When the live session ends, at that time you can put your queries, whatever you want from us, just put that in the comment section after the live end, and then I will definitely look on it, right? Okay, bye bye, bye bye, bye bye. Yes, because that is the time we have to cover in this portion, and we will cover the next in the upcoming class. All right. Okay. Bye bye. Take care, everyone. Nice meeting you all. Have a great future ahead. Okay. Bye bye. Bye bye, everyone.